Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you are rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Exam is going to conduct. So before that, there should be, majority of the students are scared about the organic. That's why only Brilliant Katha, we are proudly presenting the organic Dhamaka. So here we are going to discuss some important concepts we are going to revise the important concept from the organic chemistry. I'm damn sure about that. If you follow this one very properly, you will get a maximum question for your NEET exam. Okay. So shall we start, guys? Ready? Okay, guys. So we can go to the first question. Okay. We can go to the first question. So this is the question. Consider the following compounds. Okay. You are having some compounds they given. Okay. So there the question is, hyperconjugation occurs in. Okay. Hyperconjugation occurs in which compound hyperconjugation is occur? Yes, Rita, good evening. Okay, Atul Matthew, good evening. So let's look about the question. Okay. So here hyperconjugation occurs in. So you must not remember they given the free radicals actually. They given the free radical. These are the free radical they given. CH3. Okay. Then CH3 and here also CH3. Here CH and here benzene ring. Okay. Here benzene ring. This the free radical is here. The condition they are asking, which case hyperconjugation occurs. You must have to remember hyperconjugation will occur whenever there is a alpha hydrogen is present. That case only what will occur? Hyperconjugation will occur. So let me explain. Listen to me very carefully. So suppose this is my free radical. Okay, if it may be free radical or it may be carbocation, you can use this hyperconjugation idea here. Suppose it is to be CH3 CH free radical. Okay, CH free radical like this. Suppose it is to be like this. Okay, here one more CH3 CH3 is there. So here the one, our main hero is actually this one. Is free radical containing carbon is our hero. That attached carbon is called alpha carbon. This also alpha carbon that contain alpha hydrogen. That alpha carbon containing hydrogen is called alpha hydrogen, that we know very well. Okay, that alpha hydrogen is there. How many alpha hydrogen here? 3 alpha here, 3 alpha here. So more the number of alpha hydrogen, more will be the hyperconjugation, more will be the stability. That's the concept. So we have to check the alpha hydrogen. That's all. So alpha hydrogen should be always, you must have to remember alpha carbon is always the sp3 hybridized carbon. Okay, that idea you have to keep it in mind. Now we can check it, guys. Here we can check it. What about here? This one. This one is our main hero. That's attached to benzene ring. Here there is no carbon as well as it is sp2. Here what about this one? This is sp3 only, but it does not contain any hydrogen. So what's the meaning? Here there is no hyperconjugation. Don't think like that. Is this alpha? No, that's not alpha. Okay, our carbon free radical that's attached to this carbon. This carbon is sp3. Ready? That carbon does not contain any hydrogen. So there is no hyperconjugation here. What about the second one? What about the second one? Second one, pH means phenyl. Phenyl means benzene ring. How many benzene rings are there? 3 benzene ring is connecting with your carbon free radical. So you know that here, okay, here and here one more benzene ring, okay, one more phenyl group. So here you can see there is no alpha hydrogen. There is alpha carbons are there, these are alpha carbons, but there is no alpha hydrogen. That's it. So it also cannot show. This one also cannot show. What about this one? What about this one? Yeah, here in this case, okay, I will draw this one. I think it is clear, I hope so. While I am drawing this one, you can see guys, it's a bicyclic compound only. Here free radical is there. Here CH3 is there. Here CH3 is there. And you must have to remember that always. You must have to remember that this is our main carbon. That attached carbon is this carbon. That's actually what? sp3 only, that is alpha carbon. Okay, here it contain one alpha hydrogen is there. This also alpha carbon. This also contain one alpha hydrogen. Okay, one alpha hydrogen is there. But one more thing you have to remember in the case of bicyclic compound, this alpha hydrogen, this one is actually called the bridge head. What? Bridge head. That bridge head containing alpha hydrogen does not participate in hyperconjugation. Because if it is participating in hyperconjugation means here the free radical will come. That is not at all be stable. The free radical or positive charge or negative charge or double bond comes on the bridge head is highly unstable. That rule is called Bread's rule that we discussed in the last session. Bread's rule. Okay, Bread's rule. So if a free radical or a carbocation or a carbanion or a double bond, okay, unsaturation comes on this 2 point that is connecting with that one, anything comes means that is unstable. So this alpha hydrogen we won't consider, this alpha hydrogen only we can consider. So it can show, alpha hydrogen is there, it can show. Suppose if your compound is one more CH3 is there means no one cannot show. But here there is only one, there is alpha hydrogen is there. So that's why what's the answer guys? Only this one only, 3 only will show. So option 2 is the correct answer. I hope you got it. Yes, Sanal came. Great to see you. Okay. So Rita, is it okay, right? Atul, Matthew, Abraham, it's okay. So that's the idea. This is the idea, guys. So we can go to the next question. I hope you are watching clearly. Yeah. Great. Okay, we can go to the next question. This is the next question, guys. What about this question? In which of the following compound the CCl bond ionization shall give most stable carbonium ion? Carbonium ion is carbocation. So they are telling we can take the first compound. This is our first compound, CH3, CH3, and here also CH3, and here Cl is there. This is the first compound. They are telling like what? This CCl bond undergo ionization. That means this chlorine is taking its electron, and this chlorine is taking its electron, and it become what? Carbocation. That means this carbon is getting positive charge. That only it means. Okay, this carbon is getting positive charge. Which charge? Positive charge. I hope this green color is okay. Okay, I will write it with a white color. Okay, positive charge is there. Okay, this is the last session. So very carefully you try to listen. Okay, now. Yeah. So CH3 plus. What about this carbocation? This carbocation stability depends. Carbon free radicals stability depends on hyperconjugation. So just check it, just look it. Here this carbon is our main carbon that attached carbons. This one, all are alpha. That contain 3 alpha hydrogen. This also contain 3 alpha. This also contain 3 alpha. So 9 alpha are there. That means 9 hyperconjugation is there. And what about this one? What about the second one? This is the second one they given. You can see this is the second one they given. Here CH, okay, CH, here one H they given, and this Cl is going, then it will become plus. This is nothing. This is benzylic carbocation. Okay, benzylic carbocation. It have resonance. It has what? Resonance. How many resonance? 5 resonance are there. Okay. Then what about this one? This one you can see C, H, and here CH2, NO2. And here Cl is going means it will become positive charge. But one problem is there. This NO2 group is electron withdrawing group. Automatically this positive charge will increase again its stability decreases. The main criteria for anything is the neutrality. Stability is neutrality. They have to get anything want to get stable means they should be neutral. So here what this NO2 will do? That will withdraw the electron towards it. Automatically the positive charge increases, stability decreases. Got it? So what about here guys? What about here? CH, here it is CH3, here it is CH3 and you are getting it is plus. This is a secondary carbocation. We know that this is a primary carbocation and this is a secondary carbocation. This is benzylic carbocation. This is tertiary butyl carbocation. Out of that, which is more stable? That's only the question. So the thing is that 9 alpha containing, that we discussed in the last session also, 9 alpha, I mean in the case of tertiary butyl, the tertiary butyl carbocation is more stable than which one? Benzylic carbocation. So this one is the correct answer. Not benzylic carbocation. Okay, benzylic carbocation will be stable only with the other tertiary carbocations. This means if it is tertiary butyl means it will be more stable. Ready? Yeah, tertiary carbocation. Yes, Rita, tertiary carbocation is more stable than benzylic carbocation. That's the answer. So option 1 will be the answer. Ready? Ready guys? So we can go to the next question. We can go to the next question guys. We can go to the next one. This is the next question. What about this question? What they are telling? Which of the following is? Okay, this actually the question, these all are previous questions only, previously asked questions in AIPMT, AIMS as well as NEET. Okay. So which of the following is not the product of dehydration? Not the product of dehydration. What do you mean by dehydration? Removal of water molecule. Okay, that idea you must have to know. Then it answer is very easy. Okay, so we can take that compound. I will draw that compound here. You can see, I hope so. So this is my compound. Okay, this is my compound. And here, what is that? Here methyl is there. Here OH is there. Is it okay, guys? Yeah. Yes, yes, Rita. Yes, option 4. So here you can see, OH is there. And during dehydration, what is actually happening? From alpha, OH is going. From beta, H plus is going. Then like that only water is going. So we can see this carbon. What is alpha carbon means what? The mainly functional group attached carbon or carbocation attached carbon. I mean our hero attached one. Here our hero is OH. That attached carbon is this carbon. That carbon is alpha carbon. Okay. And that attached carbons are beta. So this is beta, and this is beta. How many betas are there? 3 betas are there. I hope you can see it. Can you see it, Rita? Atul, can you see what I'm drawing? Is it okay? Tell me in the comment box. I need your support. Yes, sir. Okay. So here you can see in this all beta. Here this beta contain 2 hydrogen. Okay. This beta contain 3 hydrogen. 1, 2, 3 hydrogen. And this beta contain 1 more hydrogen. So the thing, from alpha OH is going and from beta hydrogen is going. That only going to happen. Okay. What only going to happen? From alpha which is going, OH is going. From alpha OH is going. From beta hydrogen is going. So how many possibilities are there? This OH and this hydrogen is going. Then in between that alpha and beta double bond comes. So which option will be coming? This option will come. So that's correct. That is possible. Then what's the another possibility? You can see, guys, I am drawing the possibilities. Okay, I am drawing the possibilities. Here it is like that. Here OH is there. And this is beta. Here beta hydrogen is there. So we can think like this. We can think like it. This OH and from here hydrogen is going. Okay, from here hydrogen is going and double bond comes here. Then what I will get? From here, what is going? OH is going, and from here, what is happening? Here you can see, here double bond is coming. That also possible. So which is that? This option is possible. And one more option, one more possibility. This hydrogen and this OH is going, then double bond will comes here. That means this option also possible. This option is not at all be possible. So answer is our 4. That is not possible because that double bond comes here inside the ring. Because here only our OH was there. From here beta goes means here only double bond can come. Inside is not possible. Ready? Yes, Magashri? Ready. So answer is 4. Okay, I hope everything is crystal clear. I hope so. Ready? So we can move to the next question, the fourth question. Okay, the pair of electron in the given carbanion. Okay, given carbanion. So this is our carbanion, CH3, then C, okay, then triple bond C, here minus charge is there, okay, is present in which of the following orbital? So we know that, we know the idea, around carbon all are single bond means it is actually what? It is sp3 hybridization. That carbon is in sp3 hybridization. And if around carbon one double bond is there, that is sp2 hybridized carbon. And if a carbon that around it two double bonds are there means sp, or one triple bond and one single bond is there means that is sp. Okay, you know the idea. So here you can see this carbon is in which hybridization? sp. This is in sp3. This is in sp, this in sp. So they are asking this electron, this actually extra pair of electron that only cause the carbanion, that only cause the negative charge, that lies in which orbital? In which orbital they lies? sp orbital. So what's the answer? Fourth one, sp. Ready? Yes, yes, yes. Option 4 is the correct answer, sp. Simple. Okay guys, ready? Then we can go to the next question. We can go to the next question. I think in the last session we discussed about the tautomerism very clearly. Okay, the question is regarding tautomerism. It was a previous question. Okay, which among the given molecule can exhibit tautomerism? So I taught you very clearly in the case of keto-enol tautomerism. Okay, keto-enol tautomerism. In the case of keto-enol tautomerism, whenever you are listening, keto-enol tautomerism. Okay, keto-enol tautomerism. Okay, guys. Keto-enol tautomerism. In this case, okay, listen to me very carefully. In this case, so many times we discussed it in the class. In the so many videos we already discussed it. Some new people may be there. Okay, so yeah, yes, Rita, I am coming. Okay, so here keto-enol tautomerism. Here you must have to remember here how whether they will show the tautomerism or not. We can check it very simply. There should be a carbon double bond, or else we can think like this. Okay, a carbon should be there, that should be in sp2 hybridized, that should attach to a sp3 hybridized carbon. It should contain what? One H, that H is alpha hydrogen. It should be there means then they will show what? Tautomerism. And you must have to remember one more thing. This alpha hydrogen should not be in a bridge head. That also not possible. Okay, so we can think about it. We can come back to our question. What about here? What about here? In the first option, while you are looking the first option, guys, while you are looking the first option, okay, while you are looking the first option, it is like this. This compound is like this, and here only double bond O is there. And this is sp3. This is also sp3. So this is our alpha. I mean, this is our alpha. Okay, I'm sorry. This one, this C double bond O, that attached one is actually what? This is our alpha, this carbon is alpha, that contain hydrogen, here also contain hydrogen. But the problem is that during tautomerization, if this hydrogen is donating electron to here and oxygen is taking electron, that time double bond will come here. It bridge head, it will come. That time it is highly unstable. That was explained by bread. Okay, bread was explained like that. And if it is like that also not possible. So for this, tautomerism is not possible. Even though it have alpha hydrogen, tautomerism is not possible because that alpha hydrogen is present at bridge head means not possible. Okay, okay, ready. What about this one? This one also, here you can see the compound. This is your compound, guys. This is your compound. Okay, this is your compound. Here double bond O is there. Here benzene ring is there. Benzene ring is there. Okay. So meaning two benzene rings are there. Meaning what? Meaning there is no alpha hydrogen. Here alpha hydrogen is there. Here hydrogen is there. Alpha hydrogen only. But the problem that alpha hydrogen is present at a bridge head. That cannot cause what? Tautomerism. That is not possible. So this one also cannot show. What about this one? What about this one? The third one, it is like this. Third one I will draw here. You can see it is like this, guys. It is like this. Like this only. Here double bond O. Is it contain any alpha hydrogen? You have to check it. That's it. Is it contain any alpha hydrogen? Yeah. Here alpha hydrogen is there, but the problem is that that hydrogen is actually bridged, so it cannot cause. But here how many alpha hydrogens are there? 2 alpha hydrogens are there, so it can cause. So this is sp2, that attached sp3 contain hydrogens are there, it can show tautomerism. Ready? Ready? So this only will show, 3 only will show. So option 1 is the correct answer. The same way they can ask the questions from here also, okay? From here also they can ask the questions like this also. It was a previous one like this compound also. We discussed it in the class, we discussed it in the previous video. Even though I am telling one more time, since because I am telling one more time because some students don't know, that's why, okay? They will ask the question like this, C double bond, will this compound can show tautomerism or not? Tell me Rita, Maya, Mohini and Mayakashri, tell me, what about this one? You know the concept, Atule, you know the concept, I hope. Here, this one can show tautomerism. Why? Because sp2 hybridized carbon is there, that attached sp3 is there, that contain how many alpha hydrogen? Here hydrogen is there, here hydrogen is there. Because carbon around it 4 valencies are, so they can show tautomerism. Okay? If the compound is like this means, check it, come on. Here double bond O, here, suppose if it is like this, can it show? Yeah, it can show. Why? This is sp2, that attached one is sp3, here one more hydrogen is there. And so this one also will show. What about this one? This compound, just check it, okay, just check it. What about this compound? Double bond O and here, both are CH3 means will it show? No, it cannot show. It cannot show the tautomerism because here it is sp2, that attached carbon is this is sp3, but the problem is that there is no alpha hydrogen, so it cannot show. That's the idea about tautomerism. So you just remember about the tautomerism, because the tautomerism idea actually coming in aldehyde ketones. Okay, aldehydes and ketones, that area only it is coming whenever you are treating an alkyne with HgSO4 in presence of H2SO4, it will give you acetone, okay, in the case of acetone, and in the case of ethyne, it will give you ethanol. All other cases, acetone and the higher ketones you will get. That idea you learned already. So anyhow, we can go to the next question, guys. We can go to the next question, okay? We can go to the next question. This is the next question. What about this question? This actually, again it is coming, I mean, I already told you this actually, I am not simply connecting the question, These are all are previous year questions, okay? NEET and as well as your AIPMT and AIMS questions only we picked. So that is very important. You just go through it. This kind of question only you are going to face during your NEET exam also on May 5. Okay? Yeah, we will do it, guys. Okay. So here, which one is the most acidic compound? We know the idea in the case of phenol, okay, in the case of phenol, this H is acidic. This H will always go as H plus because phenoxide ion is more stable than phenol. We know. And if I am keeping one electron withdrawing group here means what will happen? Its acidity will increase. That idea we learned, okay. Electron withdrawing group will increase acidity of phenol. Acidity increases. And instead of that, if there any electron donating group is there, means what will happen? If there any electron donating group is there, means what will happen? In the phenol, if there any electron donating group is there, means that will donate the electron automatically. The necessity of electron in the case of oxygen will decrease. It won't take the electron from the hydrogen. Automatically its electron donating group is there, means acidity decreases. That's the concept. Now you just think about it. What about here? Here this methyl group, okay, alkyl group. This alkyl group is electron donating group because of what? Hyperconjugation as well as because of I effect, inductive effect. Here nothing is there. Here nothing to donate, okay. What about here? NO2 is a withdrawing group, electron withdrawing group. And what about this one? 3 NO2 groups are there. 3 are trying to withdraw the electron towards it. So automatically it is more acidic. More withdrawing group means more acidic. So fourth one is more acidic than the third one. Because here only one NO2 only there. What about this one? This is electron donating group is there. So with respect to phenol, it will be less acidic. So 2 will come. After that, which one will come? 1 will come. This is the order. This is the order. So what about our question? Which one is the most acidic compound? So most acidic is 4th one. Ready? Yes, I mean Joseph. Yes, Muhammad Isham. Yes, picric acid. This is called a picric acid. Yes, I hope you remember. Great guys, great. Okay. So that's the idea. So then again, we can go to the next question. I am damn sure about that. It won't be a time consuming session. Okay, it won't be a time consuming session. You don't think like that. It will be, I am damn sure it will be helpful. Okay, it will be helpful. Be with me. Ready? If you are getting the answers, mean put a fire in the comment box, please. I just want to see. Isham, Rita, Amin. Come on. That only make us fuel. Okay. Yes, guys. Ready. Waiting. Come on. So whenever you are putting fire, whenever you are putting what? That heart and all that. Yeah, great. Okay. So listen to me. Here, what about the question? Which of the following is correct with respect to inductive minus I effect of the substituents? So we know the idea, the inductive effect. Okay, in the case of inductive effect, the order is more for what? Fluorine. I mean, generally more for what? Fluorine, the inductive effect is more. Okay, fluorine, yes, it's coming guys, it's coming. Okay, so in the case of fluorine, it is more. Okay, fluorine, it is more. Then after that, which one will come? After fluorine, chlorine will come. After that, bromine will come. After that, which one will come? Iodine will come. This is actually the exact order. Then after that, OH will come. Then after OR will come. This is actually inductive effect order. Okay, inductive effect order. Okay, inductive effect order. Then after that OR, after that NH2 will come. After that, which will come? NH2 will come. After that, benzene, I mean phenyl will come. After that, only H will come. This is actually the order. Okay. Yes, Irfan, inductive effect means it is actually, Irfan, this is the last time. Okay, this is the last time. So inductive effect means it's nothing. It's actually through carbon-carbon sigma bond. So this is carbon-carbon sigma bonds are there, they are connecting. And if suppose this is a chain, here some groups are connecting. Okay, some groups are connecting. Like we can think it is fluorine. Okay, suppose I am connecting one fluorine. Then what this fluorine will do, Irfan? It will withdraw the electron towards it. Automatically this electron will be taken by this carbon. This electron will be taken by the other one. Because suppose I am taking something means automatically the one just ahead of me will take the electron from the other one. Like that. Okay. So that cumulative effect will come here. That's only called inductive effect. And this group is withdrawing the electron towards it. That's why this group is called electron withdrawing group. That only minus I effect group. And this group is actually electron donating group. They are called what? Plus I effect showing group. So plus I effect showing group only you have to remember what? Plus I effect group only the alkyl groups. I mean CH3, CH2. Okay, these groups only plus I effect showing group. This is minus I effect showing group. Because they are withdrawing electron. That's why they are getting which charge? Minus charge. So this is the order. Fluorine is having more, then chlorine, then bromine, then iodine, then OH, then OR, then NH2, then C6H5, then H. So now why OR is more than NH2? The thing is that oxygen is more electronegative. So which is the option? Which option will come? Fluorine, then OR, then NH2 will come. Option 1 will come. Ready? Yes, Kritika. Option 1 will come. That's all. Okay. Great. Okay. So we can go to the next idea. This is the next idea. This is also a previous question. Okay. Don't think like that. Why it's easy? Some of you may be having feeling it's an easy question. Okay. So it's an easy question only. Which of the following molecule represent the order of hybridization? sp2, sp2, sp, sp. Simple. I already told you. Carbon, around carbon, all the bonds are single bond, sp3. Okay, and around carbon, one double bond and the remaining are single bond. It is sp2. Okay, and around carbon, two double bonds are there. It is sp. And around carbon, one triple bond and one single bond, that also sp. Actually, the thing is that here we are counting the number of bond pair. 1, 2, 3, 4 bond pairs are there. 4 means 1s as well as 3p. That only sp3. Here how many bond pair? All the double bonds we will consider as one bond only. and this one 2, this one 3. 3 bonds are there. That's why 1s and 2p. sp2 Irfan, I hope you can follow me. What about here? This is one double bond, this is also another one, so 2. 2 means what? 1s, 1p, so sp. And here also one single bond, one triple bond also will consider as one only, so sp. That's all. That's the concept. Okay, that's the concept, nothing more. So now you can check it. What about here? This is sp. This is sp because triple bond is there. This also sp. So that's not the answer. What about the second one? This is sp2 because double bond is there. This also sp2 because around it double bond is there. What about this one? This is also sp2 because around it double bond is there. This one also sp2 because around it double bond is there. That's not the answer. What about the third one? Here it is sp2 because around this carbon double bond is there. This also sp2 because around it double bond is there. This one is sp because around it one triple bond is there. And this one also sp. So option 3 is the correct answer. Ready? Muhammad Isham, Rita, Megashri. Ready? Idea is clear? Yes. Hope so. Then 8th question also we completed, guys. So we can go to the next one. We can go to the next idea, next question. This is the next question. The most stable carbocation among the following is. Very simple. I already told you the carbocation stability, carbon free radical stability depends on the number of alpha hydrogen. Because more the alpha hydrogen, more will be the hyperconjugate. You just count the number of alpha hydrogen alone. You just count the number of alpha hydrogen alone. Megashri, Emin Joseph, be careful. Okay, answer is wrong. Be careful. Be careful. Okay, number of alpha hydrogen. What about the first case? First case I am taking here. C is there. Around C, 3 CH3s are there. Okay, Emine, listen to me. Here CH3 is there. Here CH3 is there. This one is connecting with the CH plus. Okay, and CH3. Now you just count the alpha hydrogen. Now you just count the alpha hydrogen. Here, this one is our hero. That attached carbon is this one. This is alpha. This also alpha. Here how many alpha hydrogens are there? 3 alpha. Here how many are there? 0. There is no alpha hydrogen in this carbon. This is not alpha hydrogen. This also not alpha hydrogen. This also not alpha hydrogen. This only alpha carbon. That contain no hydrogen. So how many alpha hydrogen only there? 3 alpha. Okay, 3 alpha. What about the second one? Second one, CH3, CH2, okay, CH plus, CH2, CH3. This is our hero. This is our hero, Amara hero, eh? Okay, this one. What about this? This is alpha. This alpha. Here 2 alpha. Here 2 alpha. So total how many alpha? 4 alpha. The second one is more powerful than, more stable than what? First one. So not first one. Okay, ready? Then what about the third one, guys? Can I write here? I hope so. This is our hero. That is attached with this one, alpha. This also alpha. So total how many are there? 3 and 2. So 5 alphas are there. Okay. What about this one? This one. This is our hero that's connecting with only 1 alpha. So that contains 2 hydrogen. So 2 alpha. You just count the number of alpha hydrogen. That's enough, guys. So this is the more number of alpha hydrogen in the third option. Emin, I hope you got the idea. Emin Joseph, Megashri, yes, Megashri. Yes, Rita, yes, Samriddhi. Is it okay? Yes, 5 alpha, yes, okay. Great to see that, okay. So, that's the idea. 9th question, guys. Ready? So, we can go to the next one. Next question, guys. This is the next question. What about this question? The compound that is most difficult to protonate is. What do you mean by protonation? What do you mean by protonation? Okay, you know the basic idea regarding protonation. That means if an OH group is there, okay, if there an OH group is there, that means alcohol group is there. There only you learned about protonation. Yes, Isham, I am coming. Okay, if there any OH group is there, towards that one H plus is coming. Okay, H plus is coming. So this H plus, that is only proton. That proton is coming. This proton, hydrogen contain 1 electron. H plus contains 0 electron, no electron in hydrogen, H plus. Okay, this H plus is coming for to get 1 pair of electron because H plus will get stability only when it comes like duplet, 2 electron in their outermost shell. So it is coming. That time what this oxygen will do? This oxygen will tell, okay, you take my electron. They will form a coordinate bond. So that only you are writing O. H lone pair, here H, this oxygen will be having a charge of plus. So their protonation will take place. This is actually the protonation, guys. This is actually the protonation. So you must have to remember here, out of this only one lone pair only will be donating for the protonation, that proton. Okay, if that lone pair, one lone pair is available for proton donation, then it will undergo most fastly the protonation. That's all. So now let's check it. What about here? What about in the first case? OH, H. Okay, here two lone pairs are there. Okay, this lone pair is available for protonation because if H plus is coming means it will donate that proton and it will be, it will donate that electron pair to proton. Then automatically it will form what? You learn H will be coming here plus charge. So that's actually H3O plus will be forming. So protonation is possible but little bit less because here while you are taking the second option CH3 O CH3, here two lone pairs are there and as well as this CH3 group is electron donating. Automatically in this oxygen the electron density will increase. Electron is not a sphere, it is a wave. So here the electron density will increase. So H plus can happily come and it can attach with this oxygen and it can easily donate. Okay, Ishame, Samriddhi, you made the mistake. Okay, Rita, you made the mistake. So it can easily donate because this methyl group is there that will make that oxygen electron rich again. That's it, simple. So it one also can donate. What about here? Here also one CH3 is there that can donate. What about here? It is actually phenol. What about here? In the case of phenol, okay, that pH means benzene ring. In the case of phenol, that H plus is coming to get this lone pair. That time what this benzene ring will do? It will take the electron towards it. You remember the resonance. Here it will be negative. Here double bond. This O become what? O become plus charge. So that time this H plus cannot come nearer to O. Repulsion will be there. It cannot come. Here double bond here because of the resonance. You got the point? Yes or no? Tell me. Come on. You got the idea, Samriddhi. You got the idea. So that's why which is difficult to protonate. Option 4 is the difficult to protonate comparatively. Then the most protonatable one is this one, second one, then third one, then first one, then only which one will come? Fourth one. Yes, idea is clear, I hope so. Ready now? So now we happily completed 10 questions, but I am not telling the answers for 10 questions, but along with that we are telling the concepts also. You just, if you have a note means you just note that one there because it's a complete revision. Okay, it's a complete revision. We are trying to connect all the chapters. Okay, that's all. Okay guys. Okay. So we can go to the next one. We can go to the next question. This is the next question. For carbanion, the stability order will be. So in the case of carbanion means what? Our carbon that contain negative charge. So what's the stability? What is stability? You don't want to by heart anything. What do you mean by stability? This charge should decrease because now suppose my head is somewhat carbanion. Here some negative charge is there. I will become unstable. If it can come through my body, then I will be stable. If there any possibility to resonate or if there any possibility to delocalize, I will be stable. But if it is there always, okay, some pain are there, someone is ready to take it, means I will be happy. But here, this negative charge is ready to rotate or ready to move somewhere, then it will become more stable. You just think about it. Is there any possibility to delocalize that negative charge? Then it will be stable. Okay, we can come to the point. What about here, guys? What about here? You can take the first one. I will take the first one. You can see. I am taking the first one. Here double bond, and here CH2 minus. Okay, CH2 minus. Here NO2 is there. What about NO2? What NO2 will do? Tell me what NO2 will do. NO2 will withdraw the electron towards it by using which effect? It is at ortho position. At ortho position, minus I effect will be there as well as minus R effect will be there. By using minus I as well as minus R, that will withdraw the electron towards it. Automatically the charge in this carbon will decrease. Okay, what about the second one, guys? What about the second one, guys? Okay, I will draw the second one. I hope all of you are there along with me. Yeah, yes, Muhammad Isham. Here, what about the second one? What about the second one? I am taking this one is CH2 minus, and here NO2 is comes here. What about NO2 now? NO2 here also withdrawing group, but it is at which position? Meta position. At meta position, which effect only will be available? Inductive effect only will be available. NO2 is an electron withdrawing by using inductive effect. Resonance is available at only at ortho and para equal amount. Okay, that idea you have to keep it in mind. Then what about the third one? What about the third one? Third one is this one. Okay, guys, listen to me. The third one is this one. Okay, here I am taking CH2. Here minus is there, and here NO2 is there. Here also NO2 I am having. Here also NO2 I am having. But here in the case of NO2, at para position, minus I is there, minus R also there. So resonance at ortho and para only resonance is there. Okay. By using resonance as well as by using inductive effect, this NO2 group will withdraw the electron towards it. So reduce the charge in this carbon. What about the last one? Last one. There is nothing to withdraw it. Okay, there is nothing to withdraw it. Okay, CH2 minus, there is nothing to withdraw it. Automatically that will be unstable because here everywhere withdrawing group is there. That is the most unstable one. S is the most unstable one. Likewise, how many are there? Only one option only there. That is the answer actually. That's the answer actually. But anyhow, we can start from here. Okay, so out of this, listen to me. Here resonance effect is there, inductive effect is there. Here inductive effect is there, here inductive effect and resonance effect. We know the idea, we know the basic idea. Resonance effect is more powerful than hyperconjugation effect. Than inductive, than electromeric effect. Than inductive effect. Except in the case of halogens, inductive effect is more powerful than resonance. Okay, inductive effect is more powerful than which effect? Resonance effect. In the case of what? Halogen alone. Halogen comes means inductive is more powerful. Okay, that exception you already learned in haloalkanes and haloarenes. Remaining all case resonance is more powerful. So you just think about it. You think about our question. Here, by using resonance, they are withdrawing. By using inductive effect, they are withdrawing. Here also resonance, they are withdrawing. Inductive effect, they are withdrawing. At ortho and para, resonance is equal. Then what we will look next? Inductive. Inductive depends on the position. Nearby, inductive effect is more. Far away, if at a distance, inductive effect is less. So here at ortho, just nearer to that CH2 minus, this NO2 will withdraw the electron towards it very fastly. This one, while you are looking the para, it is far away, and meta somewhat nearby. So which one will come? This is highly stable. This is highly stable because inductive effect is very nearby as well as resonance also there. By using both, they are withdrawing electron. So this is highly stable. P is highly stable. Then after that, which one will come? Here inductive is there, here inductive and resonance is there. Resonance is more powerful. Here inductive is there, but it is nearby even though resonance is more powerful. So which one will come? Meta will come. So that means R will, not meta, para will come, R will come. After that, which one will come? Q will come. So option 2 is the correct answer. I hope you got the point, guys. Ready? Ready now? So whenever you are getting the answers, whenever you are getting the ideas, you have to put some fire, some heart. Okay, it's not like your normal class now. Here I am only talking here. I cannot see you. I can feel your emotions, everything through the comment box. Okay, guys? Ready. Okay. So we can go to the next question. Guys. Mega Shri, okay. We can go to the next question. Yes. We can go to the next question. This is the next question. In Dumas method, okay, in Dumas method involved in the determination of nitrogen content, there are two methods are there. Percentage of nitrogen we can calculate. First one is Dumas method and the second one is Gelda's method, okay. So in the Dumas method, Okay, the content in organic compound in the form of how you are measuring. That you remember here we will take something KOH solution. On the above only we are collecting nitrogen. Initially we will burn our nitrogen containing organic compound in presence of copper as well as cupric oxide, and we will convert it into nitrogen gas. So how we are estimating? As nitrogen. As what? Nitrogen. It's a statement. It's the last qualitative quantitative area is important. Maybe they will ask 1 or 2 questions from there. Okay, maybe chances are there. You have to learn it. Okay, you have to go through it. So in Dumas method, that they are measuring that one by using what? Nitrogen as nitrogen. In Geldas method, that's actually taking place 4 steps, you remember. Okay, so first they will react with ammonia and they will make it as ammonium sulfate. Like that they are doing that ammonium sulfate again breaking into ammonia, then that is capturing by using NaOH, like that. Okay, so sulfuric acid, then they will do what? They will conduct what? That volumetric analysis and all that you learned. Okay, so anyhow we can go to the next idea, guys. Question number 13. This is the next question. Write the correct order of decreasing order of acidic strength. So before telling about the acidic strength, you must have to remember, okay, you must have to remember what? The mineral acids are more acidic than, mineral acids are more acidic than, mineral acids are more acidic than our carboxylic acid. Carboxylic acid. Okay, then after that only which one will come? Phenol will come. Phenol will come. After that only water will come. After that only which one will come? Our normal alcohols will come. This is actually the order. Mineral acid means HCl, H2SO4, HNO3, etc. Okay, so these are the one. So mineral acids are more acidic than carboxylic acid, than phenol, than H2O, than alcohol. That idea you must have to remember. Okay, then we can come to here. Out of this, which is more acidic? That's the question. So the thing is that while you are looking here, COH groups are there. 3, second, third, fourth contain COH groups. So automatically they are more acidic than this one. That idea you must have to remember. Then it is easy. That means one is having least acidic. Only one option is there. Answer is ready already. One is least acidic. Answer is ready. I mean, without knowing many confusions, we can eliminate. This is a previous question, okay? This is a previous question, previous options also. We can easily answer it. But I will explain, okay, what is happening here, I will explain, okay. The third one, yes, Megashri, yes, Megashri, yes. Ansila, listen very carefully, okay. So this is the third one, okay. Third one is the acidic strength. How we can tell, guys? How we can tell? First we can think about what? Benzoic acid. Here benzoic acid is there as well as phenol is there. 2 chapters they are mixing, okay. So here in the case of benzoic acid, while you are looking about benzoic acid is already weak acid than formic acid, but strong acid than acetic acid and all. You know the idea, basic ideas, you know. So here while we are looking the benzoic acid, in benzoic acid, if there any electron withdrawing group comes means, its acidity will increase. Acidity increase. And in benzoic acid, okay, if there any electron donating group comes means, acidity decrease, because it will donate the electron, automatically the tendency of hydrogen to leave as H plus will decrease, acidity decrease. That's the idea, basic idea you can remember. Now we can come back here. What about this one? You are having this is the first one you are having, okay. This is the first one, OH is there, here NO2 is there. This is weak acidic because here OH only there. But in the case of second one, what will happen? That actually contain what? COOH as well as here OCH3 group. Okay, and the second one third one benzoic acid alone. There is nothing to donate, nothing to gain. And what about here? Here you can see COOH is there as well as Cl is there. Now you just think about it, guys. Think about it. We can look the third, this 3 one, because this one is already less acidic. We know the idea because it is phenol only. It is benzoic acid containing OCH3. What about this OCH3? OCH3 will donate the electron at para position by using plus R effect, as well as withdraw the electron by using minus I effect. But plus R effect is more powerful. They will donate plus R. So automatically its acidity will decrease. What about this Cl? Cl is withdrawing the electron by using minus I effect, because in that chlorine, that inductive effect is more powerful than resonance. Here it is having plus R, but plus R is less effective, because we already wrote here. I hope you remember. Here we already wrote. Okay, here we already wrote the idea. The resonance is more powerful than hyperconjugation, than electromeric, than inductive. But in the case of halogen, inductive is more powerful than resonance. That we already wrote the idea. Okay, so that idea we already told. So inductive is more powerful. And so now tell me, a withdrawing group is there, means that will be more acidic. So out of these three, here inductive is more powerful. So that's why that is more acidic. Fourth one is more acidic. Okay, here fourth one is more acidic. After that, which one will come? This third one will come. Without anything donating or gaining will come. So that one, third one will come. Then after that, second one will come. Even though it is donating, it is a carboxylic acid. Then this one. So this one will come later only. So the answer is third one. I hope idea is clear, crystal clear. Yes or no? Yes or no? Come on guys. Okay, then we can move to the next question. Question number 14th one. Write the IUPAC name of the following. Can you write it? I am waiting. Okay. Can you write it, Rita? Can you write the IUPAC name? IUPAC name. Megashri, Emin, Samriddhi, DJ Tech. Okay, write the IUPAC name, please. What about the IUPAC name? What about the IUPAC name? Tell me the answer, please. I am waiting. Come on. Option 1, yes, Rita Amreen, that's the answer, because we have to start numbering from where? We have to start numbering from here in this double bond, and then we have to go through that. We have to cover that entire double bond, because the lowest sum rule lowest locant rule we have to apply. So this will be 2, this will be 3, this will be 4. Okay, lowest locant, because this all will become as a prefix only. So then we have to apply what? Lowest locant. There is no priority order, lowest locant, because all methoxy, chlorine, NO2 all will come as prefix only. So lowest locant we have to look. So 1, 2, 3 will come, 3, 4 will come, and 5, 6. This is the numbering order. There is no other thing. Okay, don't choose this one. Okay, 2-chloro-4-nitroanisole, that's not IUPAC name. Okay, they are asking about the IUPAC name. Okay, IUPAC name they are asking. So this is the way we have to write. Okay, so this one 1, 2, 3, 4. Here the thing is that now you can tell. While we are telling the naming, alphabetical order we have to follow. So this is chloro, this is methoxy, this is nitro. This is nitro, this is chloro, this is methoxy. Out of that, which one will come alphabetically first? Chlorine will come alphabetically first. So 2-chloro, then which one will come? Meth will come before nitro. So 1 methoxy, 4 nitrobenzene. Okay, 4 nitrobenzene. So which answer will come? Option 1 will come. Which one will come? Option 1 will come. Ready? So we can go to the next idea, next question. This is the next question, guys. This next question is also important question. Order of increasing acidic strength is. Order of increasing acidic strength is. What do you mean by it will be act as an acid means what? This compound, we can think about the first compound. If it act as a acid means what? This H should go as H plus. This H will donate electron. H will donate electron to this carbon, and it will be leave as H plus. Then only it is acidic. Am I correct? Yes or no? Then it will form what? A carbanion here. Okay? Then only it will be acidic. And if it is losing, then what you will get? If it is losing, then what you will get, guys? Just think about it, okay? What you will get, guys? Here, if it is going means here double bond is there, here double bond is there, here double bond is there. Here plus charge will come. If it is going from here, what you will get, guys? Again, if it is that is going, then that you are getting is a plus charge here. Not plus charge, I am sorry. I'm sorry. Minus charge here. Here also minus charge. Okay, I'm really sorry for my mistake. I'm sorry, chemistry god. Here minus charge will come. Whenever H plus is going, that will become minus charge. Now the concept is like this. If anything is a good acid means that will lose H plus and it will form conjugate base, and the conjugate base should be stable. It should be stable. Then only that acid will lose H plus and form conjugate base. That's why only that basic idea only we learned. Phenol. While we are looking phenol, that will always lose H plus and it will become phenoxide ion. It is a stable one. That's why only phenol is a very good acid. Ready? So we can come to here. Out of this one, these all are conjugate bases. Out of this, which is more stable, that will be the best acid. That only obtained from the best acid, strong acid. Out of this, which is more stable, how I will tell? Once you are looking this one, you just have to remember here double bond, here minus. This is cyclic. And it is planar. All carbon are sp2. Conjugation is there. Single bond, double bond, single bond, then lone pair, single bond, like that conjugation is there. And what about pi electrons? How many pi electrons are here? Here 2, as well as here 2. 6 pi electrons are there. 6 pi electrons comes means it is what? Aromatic. This one is aromatic. Aromatic is highly stable. We learned the concept. I taught you the concept what? Aromatic are more stable than non-aromatic. Than what? Anti-aromatic. Anti-aromatic is least stable. Anti-aromatic is what? Least stable. That idea we know. Okay. Anti-aromatic is least stable. Now you check about this one. What about this one? This also cyclic. Okay. Planar. All are sp2. This here also sp2. Okay. Here also sp2. Now you think about it. What we have to think? Here 2 pi electron, here 2 pi electron, here 2 pi electron, 2 pi electron. So total 8 pi electrons are there. 8 pi electrons means that obey Huckel's anti-aromatic rule. 4n pi electron means anti-aromatic. 4n plus 2 pi electron, and multiple of 4 plus 2. Multiple of 4s are 4, 8, 12 like that, plus 2. 4 plus 2, 6. 8 plus 2, 10. That, like that it comes means it is aromatic. This one, what about this one? 8 pi electrons comes. So that is what? That's actually anti-aromatic. This is anti-aromatic. This one is anti-aromatic. Okay. What about this one? This is least stable then. What about this one? This one is cyclic but not planar. This is sp2, 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 this is sp3. Because it is single bond only around it. This is non-planar. Non-planar means non-aromatic. Out of that, which is more stable? The first one is more stable than the third one. This one is least stable. Second one is least stable. Then which is the good acid? This aromatic one giving is good acid. So first one is a good acid. Very good acid. So here first one is coming. Then after that, which one is the best acid? Third one, not second one, third one, then second one. So option 3 is the correct answer. Megashri, now you got it. Now also you made the mistake, Megashri. Anti-aromatic is unstable. How it can? Then if it is anti-aromatic means this won't donate that H plus. Because if they are losing that H plus, that will become anti-aromatic. They are scared to lose that H plus. They fear to lose that H plus. Okay, ready? Yes, Rita, yes, that's the idea. So now we completed 15 questions, okay. Now we are going to the 16th one. I hope idea is clear. Now we are going to the 16th question, guys. This is the 16th one. What about this question? The correct order of electrophilic substitution reaction is. the correct order of electrophilic substitution reaction is. Listen to me very carefully. We know the idea. Benzene is electron rich. Benzene is what? Electron rich. Electron cloud. In that, a parasite is there that is attached on that benzene ring. That's actually H plus, not 1, 6 are there. Instead of this H plus is an electrophile. Instead of that H plus, by kicking that H plus, and we will send it out, and instead of that one, another electrophile is coming. That is called electrophilic substitution. So this electrophilic substitution will take place more when this benzene become more electron rich. That means in benzene, if there any group you are substituting, that group is making benzene electron rich. That means actually the electron ortho-para directive group comes on the benzene ring. Ortho-para directive means electron activating group. That means lone pair containing groups. Like that only I taught you. Lone pair containing group comes means more electrophilic substitution. And instead of that, if there any meta-directive group, electron withdrawing group, electron taking away group, okay, that group comes means that contain double bond or triple bond containing groups. That is meta-directive group comes means that make the benzene ring electron poorer. Okay, the electron density in the benzene ring will decrease. That's the idea. So electrophilic substitution will take place more in the case of benzene ring is attached with ortho-para directive group. That's the idea. You have to keep it in mind. Now we can come back while you are looking this one. What about the first one? Benzene ring is attached with which group? CH3 group. I already told you CH3 group will show which effect? Plus H effect. That means positive hyperconjugation effect. By using that only, that will donate the electron to the benzene ring. By using positive hyperconjugation effect, they will donate electron to the benzene ring. Okay. What about OCH3? The second one is OCH3. OCH3 will make the benzene ring rich by donating plus R effect. By using plus R effect, they will donate. Resonance effect, they will donate. What about Cl? Cl will make the benzene electron poorer by using what? Minus I effect. But comparatively it also contain what? Plus R effect also there. Okay, plus R effect also there. Then after that, which one will come? Here benzaldehyde is there. C double bond OH. This will make the benzene ring what? Electron poorer. That means the last one. This one make the benzene ring electron poorer. I mean the electron density in the benzene ring will be less in the case of benzaldehyde. So that is the answer that you have to check. D should come. In which case D is coming last. Here and here D is coming last. Now we have to check out of this which is having more, which will make the benzene ring more electron rich. I already told you resonance is more powerful. So here in this case inductive is more powerful in the case of halogen. So considerably more resonance is here in the case of OCH3. That means B should come. So B should come first. Then after that which one will come? Hyperconjugation will come. A. Then after that only here more than resonance which is there, inductive effect is there. So C will come. After that D will come. Because here inductive effect as well as resonance is there but comparatively less. While we are considering this one and this one, resonance is more. Okay, idea is clear? Ready guys? Yes, option 3 will come. Ready, Samruddhi, ready? Yes, okay. So the third one, this kind of question you can see in many examination, you can see that time you have to compare it. Okay, you have to compare it. You got the point, I hope so. We can go to the next one. Idea is clear, yes or no? Isham, Megashri, Rita. Idea is okay now? Okay. So we can go to the next one. Again, the same kind of question we already did. Can you tell me the answer for this one? The same kind. I mean, in the case of phenol, NO2 group comes means what will happen? Can you tell the answer? This is a previous one. I think the same question we did in our class also. Same question. Yes, Isham. Yes. Come on. Waiting. Yeah, here you can see, everyone are telling the answer. Yes, snowflake, okay. Love, okay. Great to see that, love, okay. So listen to me. Here phenol is there. Here phenol is there, okay. Phenol is there. In phenol, OH group is there. Here NO2 group comes at para position. Okay. That NO2 group. Here in the second case, NO2 group comes at where? Here phenol is there. Here NO2 group is there. Here it at ortho position. Here phenol is there. Okay. Here CH3 group is there. I mean electron donating group. And here only phenol is there. Now I already taught you we can write the effect. Which all are the effect they are showing. What about this one? This NO2 will withdraw the electron. It is at a para position, means minus I will be there, minus R will be there. What about this one? Minus I as well as minus R will be there. What about this one? This one will donate the electron by using plus I as well as plus H. Here no effect. So we are expecting here comparatively in both cases resonance is there. And then inductive, while we are comparing, this inductive is more. So we are expecting the order ortho will come first, then para will come, because more withdrawing means more acidic. So ortho, para, then phenol will come, then after that this third one will come, okay, methyl phenol, okay, para methyl phenol will come. Like that only we are expecting. But the problem is that in the case of ortho, there will be another problem is there. In the case of ortho, this nitrogen can form which bond? This nitrogen can form an hydrogen bonding. This oxygen in this NO2 will form an hydrogen bonding. Automatically, compared to para, it cannot lose that hydrogen very easily because they are in bonding, intramolecular hydrogen bonding. That's why this hydrogen is not ready to go out. So, compared to this one. So, which one will come? Para will come first, then ortho will come. So, para will come means that A will come first, then after that which one will come? First A will come, after that which one will come? B will come. So, first A, then B will come, first A, then B will come. Okay, this is not the option. A, after that B will come. Then which one will come? After A, first A, then B will come. Then after that which one will come? This one, D will come. Because here they are donating. Donating means that make the acidity decreases, that will cause acidity decrement. Okay, so after A, then B, then which one will come? That our last one will come, D will come, then C will come. Option 2 is the correct answer. Yes, the D monk code. Okay, so this is the second one is the correct answer. That's it, guys. We can go to the next question, the 18th question. What about this one? So before telling this one, I just want to make you sure that you must have to remember. You just have to remember what? You just have to remember this idea. What idea you have to remember? You have to remember in the case of carboxylic acid COOH group, some electron donating group comes here means acidity decreases. Because they are donating means automatically this H cannot leave very easily. So acidity decreases. Whenever H will leave us, H plus acidity increases. Okay. And in the case of COOH, carboxylic acid, okay, if there any electron withdrawing group is there means acidity increases. Okay. They can easily donate that H plus. Acidity increases. This is the basic idea. You have to keep it in mind. So that's why only if I am taking CH3COOH, that means acetic acid, and I am taking HCOOH, formic acid. Out of that, which is more acidic? HCOOH is more acidic than acetic acid. Formic acid is more acidic than acetic acid. Why? What's the reason? Because they will donate what? They will donate that CH3 will donate electron pair to this one, automatically that's H won't go. Okay, that's the idea. So while you are coming back, what will be the answer for this one? Can you tell me? Here they are asking about what? Correct order of pKa value. Can you tell me the acidity order? Guys? I am waiting. Can you tell me the acidity order? I am waiting, guys. Please tell me. Can you tell me the acidity order? Can you tell me the acidity order? Then I can come back. Two. Okay, so while we are looking the acidity order, you can see, listen to me carefully. Here it is connecting with what? It is connecting with the first one, CF3COOH. This CF3 is a electron withdrawing group. That CF3 is a electron withdrawing group. Electron withdrawing group means what will happen? Acidity increases. Acidity increases, okay? Acidity increases. That's the idea, you have to keep it in mind. Acidity increases. So I am writing the acidity order. So the first one will be more acidic. First one will be more acidic. Then which one will come? Then which one will come? The third one will come. Because this is benzoic acid. Benzoic acid is more acidic than acetic acid. Why benzoic acid is more acidic than acetic acid? Because in benzoic acid, listen to me carefully, in benzoic acid, this is benzoic acid, okay, this is benzoic acid, this carbon is attached to this carbon, this carbon is sp2 hybridized carbon, more S character means more electronegativity, that will withdraw the electron more faster, automatically that will be compensated, this carbon from this oxygen, automatically this oxygen will compensate from this hydrogen, that will be more acidic. What about the case of CH3COOH? CH3COOH is like this. What they will do? The CH3 will donate electron to carbon, automatically it will donate here, so oxygen won't take the hydrogen's electrons. So it will be as such. So benzoic acid is more acidic than what? Acetic acid. That idea you have to keep it in mind. So now we will get the third one is more acidic. After that, which one will come? After that, the second one will come. After that, which one will come? Fourth one. So whenever the alkyl group, the number of carbon in the alkyl group increases means acidity decreases. Because more number of carbon means more donating power. Only you have to remember the CF3 is a electron withdrawing group. Okay? Why CF3 is electron? That you already learned for your CBSE exam also you learned. CF3 is electron because of the fluorine. Because of the fluorine, they are withdrawing. That's why that ender will be act as a cumulative effect. That will be act as a what? Withdrawing group. Okay. So this is the order of acidity. This is the order of acidity. If this is the order of acidity means they are asking about pKa. This is the order of Ka value. Ka value increases, acidity increases. Whenever Ka value increases, pKa value decreases. That concept you learned in where? In equilibrium. Ka increases, pKa means minus of log Ka. Minus of log Ka will decreases. Whenever Ka increases, pKa decreases. If you want means I will tell one example, no problem. If you want means I will tell just one example, no need to. Some of you may be confused with that one. For that only, to make that only, okay, I am taking Ka value, some Ka value I am taking, okay. Ka value I am taking 1 and Ka value I am taking 2, okay. And Ka value I am taking 3. 3 I am taking. Just tell me about the pKa here. pKa equal to minus log 1. Okay, or else it will be 10, 100. Then it will be easy for me for the calculation. This will be 1000. Okay, this will be 1000. Okay, for the calculation, easy to make the calculation. So Ka value increases. Okay, what happened to pKa? Minus log 10, meaning minus 1. What about the pKa here? pKa minus log 100. Minus log 100 is minus 2. What about pKa here? Minus log 1000. That means minus 3. So that means whenever Ka increases, pKa decreases. That only the idea. So while we are looking here, this is the acidity order. Acidity increment, Ka value increment order. So what about pKa value? Just to opposite. What about the opposite means what? 1 will be less, then 3, then 2, then 4 will come. So which one will be the answer? Option 2 is the correct answer. Ready? Ready guys? Okay, then we can go to the next question, the 19th question. 19th question, we can go to the 19th one. This is the next one, guys. This is the next question. What about this question? While we are looking this one, what you are going to do, you are going to treat. Okay, you can see one compound is here. Okay, I will take that compound here. I will take that compound here. I will write that compound here. Here OCH3 is there, okay, as well as OCH3 is there, as well as here which group is there? Cl group is here, okay, Cl group is there. That you are treating with what? That you are treating with the concentrated HNO3 and concentrated H2SO4. That you are treating with what? Concentrated HNO3 and concentrated H2SO4 you are treating. Listen to me. You are treating with the concentrated HNO3 as well as concentrated H2SO4. So concentrated HNO3 as well as concentrated H2SO4 you are treating. What will happen? Nitration will happen. Nitration means NO2 plus ion will be formed from this one, because that concentrated HNO3 will act as a base. It will lose OH minus, then remaining is H plus. The remaining is NO2 plus. That NO2 plus can go to this benzene ring. Where it will go? That's the question. Where it will go? The idea is simple. This methoxy group will make this benzene ring electron rich. Electron rich. At which position? Or compared to chlorine, this is actually having more electron donating capacity. More because it is plus R effect. It is only minus I effect. So comparatively, its which position it can go. Ortho position is not acceptable because steric hindrance will be there. So it will send this NO2 to where? Its para position compared to here. So that is compared to chlorine's ortho position only. So no problem. So it will come here. It will come here. Why we are considering only OCH3 guys? Because comparatively here only NO2 will come. Here only NO2. Why NO2 is not going to here and here? Because the problem is that steric hindrance will be there because of OCH3. Because compared to OCH3, Cl is smaller one. So it can go to the para position. Why it is not going to here? It cannot go there. Why? Because two groups are there in between. Incoming is difficult. This is difficult, okay, very difficult to come to that point. So that's the idea. Ready? Yes, methoxy net effect will be predominant. Yes, guys. So which answer will come? Which answer will come? It's para portion. So option 1 will be the correct answer. Ready, guys? Ready. Yes. Okay. So we can move to the next question. This is the next question. What about this question? The correct statement regarding the comparison of staggered and eclipsed conformation of ethane is. You remember the staggered as well as eclipsed conformation of ethane. Like this you learned, guys. I hope you remember. This is the Newman projection I am drawing. Newman projection you learned. Okay. Newman projection you learned. I hope you remember this idea. Here hydrogen, and here hydrogen. This actually eclipsed just behind one. Okay, then again one more you learned, this one you learned. I hope you remember this the one. Okay, H here, you learned the idea here what? Here H is there, here H is there. This is actually the staggered one. Out of that, which is more stable? Staggered is more stable than what? Eclipsed. Why? In the case of staggered, the torsional strain is less. The strain because of the front one, that's only called the torsional strain. That is less, that is more here in eclipsed, and there is no torsional strain here. They can far away only, there is no repulsion. So which one will be the correct answer will come? Here the staggered conformation of ethane is less stable. That is wrong. Staggered is more stable. Here the eclipsed conformation of ethane is more stable. That's wrong. So here the eclipsed conformation of ethane is more stable. That is also wrong. What about here? The staggered conformation of ethane is more stable than eclipsed conformation, because staggered conformation has no torsional strain. Option 4 is the correct answer. Yes, guys. You have to read the statements properly, then you will get the answer. You need patience. Okay. While you are looking the options, you need what? You need patience, means you will get it. Okay. Yes. Gauche is different. Okay. Gauche form is same. Not like this one. Gauche we are not explaining for this one. That's for what? That's for butane. Okay. So in that case also completely staggered is there. And what? Gauche form is there. And what? Completely anti is there. That's different. Okay, that's different case. Okay, you have to remember this one. This is enough for you. Okay, fine. So we can go to the next one. This is the next one, which is the correct order of acidity. but they didn't give what? They didn't give any phenol, they didn't give any alcohol, they didn't give any what? Carboxylic acid. They given this one only. What? Alkyne, alkene and alkane only. How we will tackle it? That also idea also you learned. Listen to me. CH triple bond CH. Okay guys, CH triple bond CH. Here the carbon is in sp hybridization. CH2 double bond CH, and I am writing one more H here. Okay, you can see guys. Here one H I am writing here, one H I am writing here. This is sp2, and one more I am writing CH3 CH H. Okay, this carbon is in sp3 hybridization. The thing is that in sp hybridization, percentage of S character is 50%. In sp2 hybridization, percentage of S character, okay, percentage of S is 33.33%. In sp3, it is only 25%. And you just learn the idea, percentage of S character increases, electronegativity increases. So here the percentage of S character is more. So what this carbon will do? Can you see? Its S character is more. What that will do? Its electronegativity is more. What it will do? Electronegativity more means that will take the electron from this hydrogen and lose that hydrogen as, allow that hydrogen to go as H+. So that's why it is acidic. So the terminal alkanes, listen to me carefully, terminal alkynes, that means the triple bond comes on the terminal position, okay. Terminal alkanes are acidic than this one, because here sp2, comparatively less S character only, so less acidic. This is very less acidic. Okay, now ready? So alkynes are acidic. Which alkyne? Terminal alkynes are acidic than alkene, than what? Alkane. And you have to remember, this is weak acid than alcohol, our alcohol, okay. So that idea, if you know, means you can answer this question. What about this one? Here it is alkene is coming first, that is wrong. What about the second one? C triple bond CH, then CH3 C triple bond CH. One more idea they are telling. CH3 C triple bond CH as well as CH triple bond CH. Out of that, which is more acidic? This one is more acidic because it is sp, and this is also sp. But the problem is that whenever some big alkyl group comes, means this alkyl group is electron donating. Automatically the tendency of this carbon to withdraw that hydrogen will be decreases. So the among alkyne, the more higher acidic one is ethyne. Ethyne is more acidic one. So which one will be coming here? Ethyne is more acidic than this one, than this one. Option 2 will come. Option 2. Ready guys? Yes, Venkata Subba Reddy Modkala. Yes, option 2 is the correct answer. Ready? Yes. Then we can go to the next question. 22nd question guys. 22nd one. This is the question. An hydrocarbon that react with bromine by substitution to form an alkyl bromide, okay. So hydrocarbon react with bromine by substitution to form an alkyl bromide, which on Wood's reaction is converted to gaseous hydrocarbon containing less than 4 carbon atom. So they are asking about hydrocarbon A. Some hydrocarbon A which on treatment with bromine. So substitution reaction. Substitution is possible for alkanes. So we can eliminate this one. Alkyne we can eliminate. Alkene we can eliminate. Substitution is for what? Alkanes only. Then what they are telling? So if it undergoes substitution, what you will get? CH3, CH2, Br will get. Because one instead of hydrogen, one bromine will come. And if we are conducting what? Wood's reaction. Wood's reaction means bromine, CH2, CH3. Okay, and in presence of 2Na, it will go, 2Na will go in presence of dry ether. So what you will get? CH3, CH2, CH2, CH3. But here how many carbons are there? 4 carbon. But what they are telling? Less than 4 carbon you are getting, means option 4 is the correct answer. Option 4. Yes, Rita. Yes, Ash. Yes, Juice. God speed. Okay. So the answer is 4th one. Ready guys? Ready. So we can go to the next question, 23rd one. It's an interesting question, guys. What about the question here? The compound C7H8. That time itself you have to remember C6H6 is benzene. So what do you mean by C7H8? That is none other than toluene. That's actually toluene. Toluene. Okay, CH3. That is toluene only. You just think about it, okay? Because C6H6 is benzene. Instead of one hydrogen, that is phenyl. Then one CH3 is coming. That is C6 means C7H8 is coming. That is toluene. Okay, ready? Then that one you are treating with 3 chlorine in presence of heat. That means free radical substitution will take place. Which reaction will take place? Free radical substitution, not electrophilic substitution. If it is AlCl3 means chlorine will come in the benzene ring. If it is heat or in sunlight, that time what will happen? Here instead of H, how many chlorine will come? Here instead of H, 3 chlorine will come. CCl3, it will become CCl3. Ready guys? It will become CCl3. Ready now? Now after that what you are doing? I hope you got the point, because if I am writing this one like this, okay, if I am writing toluene, if I am writing this one with chlorine in presence of AlCl3 or FeCl3 means this methyl group will send the chlorine into ortho as well as para position. That is different. That is what? Electrophilic substitution reaction. But here it is in presence of delta. Here only, instead of hydrogen only, chlorine will be substituted. How many chlorine are coming? 6 chlorine are coming. 3 chlorine will go with 3 hydrogen and they will form 3 HCl. And remaining 3 chlorine will come and attach here. Okay, that's the compound. After that, what you are doing? You are treating that one with bromine in presence of Fe. So now what will happen? Now electrophilic substitution. Here bromine plus ion is coming. That will send. What about CCl3? What about CCl3? CCl3 will show minus H effect. Which effect? Minus H effect. So they are actually meta-directive group. Meta-directive group. Okay, meta-directive group. They are meta-direct. CCl3, CF3, etc. are CCl3, CF3, etc. are meta-directive group. Okay, so they will direct this bromine towards where? Meta they will direct, okay. They will direct towards meta position. CCl3 will direct them towards meta position. Here that bromine will come. After that what you are doing guys? You are treating with zinc bar HCl. Whenever you are treating zinc bar HCl or metal bar acid, metal react with acid, you will get what? Hydrogen. You learned in some LKG classes, I mean 10th standard or 9th standard, you learned this idea. Metal react with acid, they will provide what? Hydrogen. So what is happening here? Hydrogen is providing. So instead of this chlorine, which one will come again? Again chlorine will come. So it will be CH3 will be there. Here bromine will be there. So what's the answer? Meta-bromotoluene. Meta-bromotoluene. Option 1 is the correct answer. Yes, Muhammad Isham. 1 is Venkada Subbareddy Motakala. Yes, option 1 is the correct answer. Great to see that. Okay, great to see that. Yes. Rita Rahman, option 1. That's the idea. Got it. So next we can go to the next question, guys. Next one, I hope you are following very clearly, very thoroughly. Okay, so this one, you learned this idea, CH triple bond CH. If we are taking this acetylene in presence of what? Red hot iron tube. Red hot iron tube at 873 Kelvin, if you treat means it will become what? Benzene. It will become benzene. That reaction you learned, how it is happening, that you know. How it is happening, that you know. If you know that idea means it is easy. It's easy. What's the idea? Here I am taking one CH triple bond CH, okay. And here another CH triple bond CH, okay. And here another CH triple bond CH. 3R I am taking, okay. CH triple bond CH. 3 acetylene I am taking. Then at a high temperature, that means red hot iron tube only we are treating. What will happen? Red hot iron tube only we are treating. What will happen? then in presence of high energy you are giving, this triple bond will break. How this triple bond will break? This one electron will be given to this carbon, one electron will be given to this carbon. Here also it will break, one electron will be given to this carbon, one electron will be given to this carbon, one electron will be given to this carbon, one electron will be given to this carbon. Now how it will be become? I will draw it here. You can see guys, here CH, now it will be double bond CH. And here in this carbon one electron is there. Here also it will be become free radical. And what about here? CH is there, that double bond CH. Here also what will happen? Here also one free radical, here also one free radical. What about the above one? Here also what will happen? CH, double bond CH. Here also free radical will be there, free radical will be there. You know, single will always try to mingle. So what will happen here? You can see this single and single will form a bond, mingle. This single and single will form a mingle and they will form a bond. This will form a bond. Now what is this? Alternative single bond and double bond, and 6 carbon are there. That is none other than benzene. This one only you are getting. This is the idea. This is the idea. Now instead of that one, yeah, they form benzene, okay. Instead of that one, what they given now? They given what? They given propine, they given. So how we will write it? How we will write it? Very simple, okay. How we will write it? Propine I will write like this. You can see CH, okay guys. CH, triple bond C, here CH3, okay. And again CH, okay, triple bond C, and along with that CH3. And CH, triple bond C, along with that CH3. What's the idea I taught you now? What's the idea I taught you now? This triple bond will break and it will be become double bond. And here one electron will come, one free radical will come, one free radical will come while you are heating, okay. That triple bond will break. That's the idea, you have to keep it in mind. Then here also that triple bond will break. Then it will be become what? It will be become, the triple bond will break, it will be become double bond. Here also that triple bond will break, okay. Here also that triple bond will break. Then it will be become double bond. Here everywhere single electrons will come. So single become what? Mingle. They will mingle. This will mingle. This will mingle. So how I can draw? How I can draw properly? I will draw it properly. You can see guys. I hope you can see it. This one I am drawing like this. This carbon I am connecting. This one I am connecting. This is the compound I am getting. This compound is called 1, 3, okay, 1, 3, 5 trimethyl benzene, or it is called mesitylene. They are asking how many sigma bonds are there. That's the question. How many sigma bonds are there? What's the answer? How many sigma bonds are there, guys? You just count it. How we will count the sigma bonds? I hope you know the idea. Here along with the hydrogen 3 is there. Here also, yeah, along with this carbon 3 is there. Then 4th one, 5th one, 6th one, 7th one, then 7 plus 3, 10, 11, then 12th and 13. Okay, note that one. 12th, 13. Then 14 plus 3, 17, 17 plus 1, 18, okay, then 19, 20 and 21. 21 will be there. Or you got the answer? Ash, you are not counting this hydrogen. Here also hydrogen is there. That you are not counting. That hydrogen also you have to count. 3 hydrogen also there. This is the structure. This is the structure you are getting. This is the structure you are getting. One CH3 here, one CH3 here, one CH3 here. Don't forget about the hydrogen here. Here hydrogens are there. That also you have to count. That you are forgetting. That's why. So how many sigma bond? 21 sigma bonds. 21 sigma bond. Okay. Yes guys. So answer is 21 sigma bond. Option 1 is the correct answer. I hope you are getting. Ready. Yes. Okay. So we can go to the next question. We can go to the next one. This is the next one. The most suitable reagent for the following conversion is. This idea also you learn. This actually I am taking butane, but2yne I am taking. This one I am treating with Lindlar catalyst. Lindlar catalyst, that will be become C double bond C, CH3. Okay, you learn that idea. Here H will come. And similarly, if I am taking C triple bond C, here CH3, here CH3, here H will come. if I take sodium in presence of ammonia, that one is called Birch reduction. Birch reduction, okay. Pronounce it properly. Birch reduction, okay. That idea I taught you in the class, you remember? Yeah. So what is Lindlar catalyst? Partially deactivated palladized charcoal. Because if you are taking simply palladium means that contain enough amount of hydrogen, that we have to deactivate it by choosing charcoal as well as what? Quinone. So what's the answer? Hydrogen in palladium. Carbon is charcoal and quinoline. Okay, so this one, second one is the correct answer. Ready guys? Yes, Birch reduction. You learn it. Okay, so we can go to the next question, 26th one. Guys, we completed 25th question. We completed. Now we are going to the 26th one. What about this one? While you are seeing this one itself you will understand. Yeah, this is oxymercuration, demercuration. During oxymercuration, demercuration, you have to add water according to Markovnikov rule without any rearrangement. That idea you have to keep it in mind. Okay, whenever you are seeing oxymercuration, demercuration, okay, you have to add water without any rearrangement, that idea you have to keep it in mind, without any no need of any rearrangement. Okay, so here we have to add. So this is your compound. You can see CH3, CH3 and CH double bond CH2. What is Markovnikov rule? Rich become richer. Okay, so that means what is rich here? This hydrogen, this carbon, you can see. Can you see this carbon? This carbon is rich in hydrogen. That carbon is rich in hydrogen. 2 hydrogens are there. But this carbon is poor because around it only 1 hydrogen is there. So we have to add what? We have to add H2O. H2O means H plus is there, OH minus is there. Where this H will go? H will go and attach to here, and OH will go and attach to here. Rich become richer means H will go to the richest carbon and OH will go to this carbon. So what will be the answer we are getting? Fourth one is the correct answer. I hope you got the idea, guys. Yes or no? It's a direct question. If instead of this one, if I am conducting hydroboration oxidation means anti-Markovnikov addition, I mean BH3 or B2H6, if I am using in presence of THF, then I am reacting with H2O2 means what will happen? Anti-Markovnikov addition will take place. You remember that idea. Okay, so then we can go to the next question. What about this question? Yeah, great to see this question. What about this one? What about this question? I will write the idea clearly. You can see CH triple bond CH. This one if I am treating with H2SO4 in presence of mercuric sulfate, okay, HgSO4, you know we have to add H plus as well as OH minus. So this bond will shift to here, this carbon, then this will become CH double bond CH in one carbon. In here it is actually what? Negative. So here only H will come and attach, here OH will come and attach. Okay, this compound is actually enol. You remember it's an enol because double bond is there as well as OH is there. It's an enol. This will rearrange. That's called a tautomerism. And this H will donate. Okay, I will draw this one here. You can see properly. OH only. This H will donate. This H will donate electron to this carbon, and so this will be what will be happening? This will be shifted to here. So what is happening? This become CH double bond O. To that carbon only this H will go and attach CH3. You will get ethanol. But instead of this one, if I take any other alkyne, I am taking RCH triple bond. I am taking RCH, RC triple bond CH. That time I am treating this one with H2SO4 in presence of HgSO4. You learn the reaction. This will become RC double bond CH. Here negative charge will come. Here positive charge will come because the carbocation should be always inside. Okay. So here which group will be go and attached? Here H plus will be go and attached. Here OH will be go and attached. So now they will rearrange. How they will rearrange? This will become RC double bond O CH3. It will be a ketone. So if you are taking alkyne, I mean ethine, it will be always ethanol, and other than any alkane you take means you will get a ketone. Okay, that idea you know means we can come to our question. We can come to our question. This is our question. This is our reagent. Okay, this is our reagent. What's our reagent? They given one. I think it is. I will draw here. You can see. This is our reagent. Okay, this is our reagent. Here C is there. That connecting with the C, triple bond CH. That you are treating with. That you are treating with what? You can see HgSO4. H2SO4 in presence of D2O. Okay, listen to me carefully. H2SO4, HgSO4 in presence of D2O. Whatever it may be, the first from H2SO4 you will get H plus. From D2O you will get what? D plus as well as OD minus. The first step is electron shifting. This will shift to here only because it is donating group. It will shift to this direction only always. So now it will be become what? That idea you must have to remember. Okay, so here it will be become C, double bond C. Here it will be CH. This will be minus. This will be plus. Now we have H plus is there from the sulfuric acid and D plus is from the D2O. Which one will go and attach to the negative charge? H plus and D plus both will try to run towards the C minus, but H plus will come first because D minus, D plus means that is heavy water, that heavy hydrogen, that heavy, its mass is more, so it cannot run faster. So it will go and attach here faster. Ready? Idea clear? So here which one will go and attach? H plus will be attached here. Okay, H plus will be attached there. Ready? And then in next step, OD minus will be there. OD minus SO4 minus is there. OD minus will be attached here. Okay. So what compound I will get? You can write like this. Here this one is there. Here C is there. Here OD. Okay. OD is there. Then here double bond CH2 is there. This is actually a. You can see guys. You can see. This one, what it will do? It will undergo some rearrangement. How they will rearrange? This D will donate electron to here, so it will be become double bond. So this will be shifted to here. Now how I can draw? I will draw that one here. You can see I am drawing that one here. You can see guys, that will be become here. That ring is there. 6 carbon ring is there. Here it will be C. C is there. Here which bond will come along with the C? Here it will be become double bond O. Okay. Here it is actually CH2, that CH2, here is CH2 that is getting, so that is negative. From here D is donating that electron to here, so D will come as D plus, that D plus will come and attach here in CH2. So I can write in CH2 which is coming and attaching D plus, so CH2D. This is our answer. This is our answer. Idea is clear, right? So yeah, D plus will come and attach. So you just check it. Is there any option like that? Here which one will be there? Here double bond O will come. Here CH2D should come. Is there any option like that? Yeah, option 1 is like that. Okay, option 1 is like that. Yes, correct. Option 1 is the correct one. What about the second case? You are taking HgSO4, H2SO4 in presence of water. That time what will happen? That also we can explain here itself. Okay, no need to draw it again. No need to draw it again. Here again you are using water means what will happen guys? Instead of OD minus which will be there? OH minus will be there. So here OH minus will come. Here OH minus will come. So that H will go. Here it will be also H. That means it will be CH3. I hope you can compare it. Okay, normal ketone. Rita, yes, normal ketone. So that means this will get, the second option will get. What about this one? BH3, THF in presence of H2O2 and OH minus. You learned this idea guys. If I am taking an alkene, okay, an alkene, and I am treating BH3 in presence of THF, okay, in presence of THF, and what? H2O2 OH minus will give what? RCH2 CH2OH. But if I am taking an alkyne, I am treating this one, it will give you what? H2O2 OH minus, it will give you what? It will give you RCH2 CHO you will get. You will get an aldehyde. You will get what? An aldehyde you will get. you will get an aldehyde. Okay, you will get an aldehyde. So what will be the answer? You will get an aldehyde. So that means here CH2, CHO will be coming. Option 1 is the correct answer. Ready, guys? Ready. Rita, Ash. I think so many are coming. So many are not. I hope this is beneficiary, right? I hope so. You are getting the concepts. Ready? So 27 question we completed. 27 question we completed. We have few more questions. Okay. Listen to me very carefully, guys. It will be helpful. The next one. This is the next question. Which of the following is the major product in the reaction of HOBr with propene? What is propene? Propene is this one. CH3, CH, double bond CH2. This is propene. This one you are treating with the HOBr. Okay. So what will happen? The normal, you learned about HBr. Like that only HOBr. Markovnikov rule will take place. How it will split? It will split as Br plus as well as OH minus. Here exactly we must have to know what is Markovnikov rule. According to Markovnikov rule, during the Markovnikov rule, the negative part of the addendum means what we are going to add to an unsymmetric alkene, okay? The negative part of the addendum will always go and attach with a less number of hydrogen containing carbon. So which is the negative part of the addendum? This one is the negative part of the addendum. This will go and attach with always with less number of hydrogen containing carbon here. And this Br will be go and attach with here. So what product you will get? CH3 and CH. Here which one will come? Here OH will come. Here it will be CH2Br. So what's the name? 1, 2, 3. 1 bromo. And the remaining is propanol. So 1 bromo, propanol, or else 1 bromo, 2 propanol. Option 4 will be the correct answer. Ready. Okay, so that's the 28th question. We can go to, I'm not wasting your time. We can go to the next question. Which of the alkenes will give same product by any method out of hydration? Hydration means simply you are adding water. H2O you are adding, dilute H2O, so for in presence of dilute H2O, H plus and OH minus you are adding, okay. That time rearrangement is possible. And hydroboration oxidation. Hydroboration oxidation we already told, BH3 THF that presence. That means anti-Markovnikov addition. And oxymercuration, demercuration. That is normal Markovnikov addition without any rearrangement. In all case, if you conduct also, you are getting same product in which case? So here you can see this actually what? Unsymmetric alkene. What do you mean by unsymmetric alkene? Here in this around this double bond, this carbon contain 1 hydrogen, this carbon contain 2 hydrogen. This unsymmetric. This will give a different products in different cases. In first case itself, while you are taking CH3, CH double bond CH2. In the case of what? In the case of hydroboration or oxidation itself, that will give you what? Here OH will come, here H will come. And in the case of oxymercuration, demercuration, here OH will come. Oxymercuration, demercuration, I'm sorry. Here OH will come, here H will come. Okay, that is Markovnikov rule. In the case of hydroboration, just opposite will be takes place. CH3, CH2, OH you will get. You will get a different product, not that one. This one also same, because here also unsymmetric only. This one also unsymmetric only, because around it the number of hydrogen atoms are different. This one is symmetric, because here you add H, here you add OH, or here you add OH, here you add H also. Answer is same. So option 2 is the correct one. I hope idea is clear. No need of explanation, right? Mohammad Isham, Emin Joseph, it's AK. No need of explanation, right? If the ideas are clear, means now we completed 29 questions. 29 questions and 290 more concepts we discussed, guys. So you have to burn the fire. We have to burn the comment box. Okay. Venkata Subbareddy Modkala. Okay. Yes. So we can go to the 30th question. This is the 30th question. What about this question, guys? What about this one? The same way. Where is Megashri? I hope she is sleeping. Okay. Megashri, come on. So what about this one? This also Br2 bar CCl4. What we are doing? We are conducting electrophilic substitution. So electrophilic substitution means out of this, which one will make the benzene ring more electron rich? OH will make the benzene ring more electron rich than OCH3, than CHO will make the benzene ring electron deficient. OCH3 will make the benzene ring electron rich. And OH will also make the benzene ring electron rich. But which make more electron rich? OH is the more make electron rich. Because it is it is always electron donating only, electron donating group, that will make it more electron rich OH group. So now this OH group only we have to consider either its ortho portion or its para portion only. Br2 means from there we are going to get Br plus. So this here it is para portion is here, there is already CHO is there, then where only it can go and attach? It can go and attach only at the ortho portion. So here CHO is there and here OCH3 already there, here OH already there. Its para position is already filled with CHO, ortho portion OCH3 is there, then Br will go only to here. So what will be the answer, guys? What will be the answer? Option 2 is the correct answer. Yes, snowflake, yes, okay. So option 2 is the correct answer, because out of that, which will make the benzene ring more electron rich? Out of this, OH will make the benzene ring more electron rich. So that only will be the commanding. So if 3 persons are there, out of that, which one is more powerful means which one is more commandable. So which is more commandable, which is more electron donating? OH. Its effect only will be always predominate. Okay, ready? So 30 question we completed, guys. Again we have to go to the next idea, the reaction. The reaction is a simple direct question. C6H5, CH, double bond CH, single bond CH3. Okay, this one you are treating with HBr. You are treating with HBr, predominate. So whenever, you must have to remember, whenever you are adding HBr, the normal Markovnikov rule means that time you have to remember the first priority is what? That H plus will be adding first. So H plus will be adding first, okay. So here H plus is adding first. 2 possibilities are there. Either H plus can come and attach here in this carbon or here. So suppose this is shifting to here, okay. This is shifting to here. Then now what you will get? You will get C6, H5, CH, single bond CH, CH3. This will be become negative, this will be become plus. Now H plus will be attached here. Now you are getting benzylic carbocation. It is highly stable. Benzylic carbocation. It is highly stable one you will get. What about this one? If it is shifting back, okay. Suppose instead of this one, if it is shifting to here means what will happen? You will get this one. What you will get? C6, H5 and CH, single bond CH, CH3 you will get. Here negative will come, here plus will come. This negative only, which one will be coming and attaching? H will be coming and attaching. Now you will get a normal secondary carbocation that is unstable. So this is more stable. So that benzylic carbocation only more stable. So further reaction means here only Br will be come and attach. So option 4 is the correct answer. Yes, Isham. Option 4 is the correct answer. Is there any rearrangement possibilities there? There will rearrange. Okay. Anyhow, option 4 is the correct answer. Ready? Ready. So we can go to the next one. We are coming to the chapter haloalkane. I think you remember this question. 2 possible stereo structures of CH3, CHOH, COOH. What is that? This is the one. You can draw like this. CH3 is there. Here C is there. Okay, it is connecting with H. Here it is OH. Here it is COOH. 2 possible structures which are optically active. Its mirror image I can draw. How I can draw the mirror image? Here CH3 will be there. Here COOH will be there. Here OH will come. Here H will come. Both are optically active because this one are asymmetric. This is a stereo sender. This is also stereo sender. Then they are called, they are optically active and optically active and mirror images. Then they are called what? Enantiomers, not mesomers. Mesomers only for one compound. You remember, I hope, guys. Okay. Then diastereomers means they are optically, either it may be active or it may not be active, but they are not mirror images. These are mirror images, okay. Not atropisomers, okay, not that one. So you remember this one, enantiomers, mesomers, diastereomers. You remember the guys now? So the answer is what? Enantiomers, okay. Easy one. This is the next question. In SN1 reaction on chiral centers, SN1 means substitution nucleophilic unimolecular, means that purely based on what? Carbocation mechanism. That time we are expecting what? We are expecting a racemization. I mean both possibilities are there. They are forming what? Suppose this is my compound, means this is my compound, means this chlorine is removing the electron and taking the electron, and it is forming what? You remember they're forming carbocation. Now the nucleophile can either attack towards the front as well as towards what? Back. They can come and attach. They can come and attach, but they will always prefer what? They will always prefer what? The backside attack only they will always prefer. So which will be more? Inversion will be more than retention, leading to partial racemization. Not 100%. Okay, that is wrong. Not 100% racemization. This question we discussed in the class also. Not 100% racemization. Here inversion is always more than retention. Okay, inversion, because the majority here also what the nucleophile will do? Nucleophile will try to come towards the backside attack. They will try to come. Okay, they will try to come to the backside will be more. It is found that. Okay, so the answer is what? Inversion is more than racemization only, but inversion will be more than retention. So they will form what? Partial racemization. Okay, ready? Don't forget it, Rita. Don't forget it. Okay, Emin Joseph, Muhammad Ashim, Hisham. Don't forget the idea. So that's the concept. Okay, next question. This is a previous question in NEET question. Which of the following biphenyl is optically active? Yes, Rita, I hope you remember this question. Okay, so here the main criteria for optical activity, while they are telling big compounds, means you have to remember that molecule should not be in a plane. Then if it is not in a plane, means there should not be any symmetry. So what about, you can see my hand. Okay, now I am keeping this one like this, means they are in one plane. If I am keeping like this, means you can see, I hope so. Okay, this is like this direction, this is this direction. Okay, so like this means there is one in one plane, this one in this plane. Okay, so that is not in same plane. We cannot get two equal half. That idea you have to keep it in mind. Now I am checking, what about here? This is sp2, this also sp2. They are plane, and here hydrogen is there, here hydrogen is there, here hydrogen is there, here hydrogen is there. They are in plane only. What about this one? While you are looking this one, you can see, guys, while you are looking this one, okay, I'm drawing benzene. Here all are sp2, and here Br is there, here I is there. Okay, and this one also benzene is there, here Br is there, here I is there. So the problem, we are thinking like that all are sp2, all are in same plane, but the problem is that this Br and I, now this is in same plane, but this is a bulkier group. This bromine, this iodine is a bulkier group. So what they will do? Now they are in same plane. Can you see? I hope so. You can see they are like this. Okay, they are in the same plane, like this only, in the same plane. This also in the same plane. Can you see? I hope so. But both are in the same plane, like this only. They are standing. Okay, I hope you have to remember, this is bromine, this iodine, this also bromine, iodine. Okay, but because of the steric hindrance, because of the large size, because of the repulsion, they will simply rotate like this. Can you see? Guys? So initially it was like this. Okay, I hope you can see. Guys. You can see. Initially it was like this in the same plane. Okay, it's in the same plane, but because of the bulkiness, it will rotate like this. Okay, I hope you can see. I hope so. Yes, it will rotate like this. So now there is no, it is not in the same plane. We cannot cut it into two equal half. So that will give the optical activity. Second one will give the optical activity. But here there is no, because it is sp2, everything is sp2, and here it is H only coming. There is no such kind of rotation. Here also H only coming, no such kind of rotation. So you have to remember, if it is out of the plane, means possibility is more to form what? To form the optical activity. That idea you have to keep it in mind. So answer is which one? Second one, guys. We can go to the next idea. This is the next idea. What about this idea? This is the question they are given CH3, CH2, Br, okay, plus NaCN. Okay, that you are treating with the CH3, CH2. I mean that will become CH2CN plus NaBr. You know that this is Br, instead of that Cn is coming. nucleophilic substitution reaction. What about this one? This is secondary only. Secondary will undergo nucleophilic substitution means it is actually which reaction? SN2. SN2 is possible in polar aprotic medium. That is which one? That is this one is polar protic medium, H plus only they will provide. This also methanol also will provide H plus, polar protic only. This one water also will provide polar as well as they will provide H plus. This one NN dash dimethyl formamide, they are polar aprotic medium. So third one is the correct answer. Yes, that you learned, I hope. Remember, okay. So this one, SN1 will be more possible in SN1. If it is SN1 means it will be more possible in polar medium because the carbocation mechanism means charged mechanism. The charged mechanism will be possible in charged medium. Charged medium means polar medium. Okay, that idea you have to keep it in mind. Okay guys, great. Okay, then we can go to the next question. This also previous question. Among the following, the reaction that proceed through electrophilic substitution. Is it electrophilic substitution? This is benzene diazonium chloride. That instead of that chlorine is coming. That is not electrophilic substitution. Okay, that's not electrophilic substitution. That is decomposition only, that one. That is not electrophilic substitution. What about this one? Yes, this is electrophilic substitution. In benzene ring, chlorine is substituting instead of hydrogen. That is electrophilic substitution. What about this one? This is free radical substitution. Okay, free radical substitution only, this one. Free radical only, that one, in presence of UV light. What about this one? This one, nucleophilic substitution only. This one is nucleophilic substitution only. Here instead of OH, here Cl is coming. I hope you can see it. Okay, so what's the answer? Second one is the correct answer. Okay guys, I'm going to the next question. Okay, these two questions, no need for us. Okay, this is the next question we are going to do. So the thing is that whenever you are getting the time means, I mean, I'm going little bit fastly, but not much more, because whenever you have doubt means you can drag it again and you can watch it. Okay, no problem. You can put the comment in the comment box. Okay, don't worry. So this is the next question. Reactivity order of SN1 is SN1 purely based on what? Carbocation mechanism. So this Cl I am removing. So here I will get plus. This Cl I am removing. Here I will get plus. This Cl I am removing. Here I will get plus. This Cl I am removing. Here I will get plus. Now what I have to check? More the stable carbocation, more will be the SN1 mechanism. How I will find the more stability of carbocation? By counting the number of alpha hydrogen. Here how many alpha hydrogen are there in the first case? 5 alphas are there. Okay, now you remember this one, that only 5 alpha carbons are there. Okay, what about here? Here while you are looking here, how many are there around it? Here 3, here 2, 5 alpha are there. Okay, 5 alpha are there. Ready now? And one more problem is there. What about here? Here while you are looking, this is 9 alpha are there. What about this one? Here it is only 2 alpha are there. And one more possibility is there. What about that second one? You can see in the case of second one, this is phenyl. Okay, phenyl comes means that time you have to be more cautious. So here CH2 is there. Here CH plus CH3 is there. Listen to me very carefully, guys. Listen to me very carefully. Can you see this CH2? That CH2 I am drawing like this. CH I am drawing like that. Suppose this hydrogen is taking this electron and it leave us H minus, and this will be become plus, and this H minus is going to attack here, then it is coming here, that will be we will get what? Benzylic carbocation we will get. That's a possibility of benzylic carbocation because of the rearrangement. That rearrangement I taught you in the class, 1,2 hydride shift. 1,2 hydride shift. I will write it here properly. You can see. I will write it here one more time. Okay, for your purpose only I am writing this one CH2. This is CH plus here, and here it is CH3 means what I told you. This is the carbon, this containing hydrogen. Okay, that hydrogen 1,2 hydride shift. 1,2 hydride shift means from this carbon, the one of the hydrogen will go to there. So what will happen? What will happen, guys? You can see what will happen. Here it will be CH. Here that CH is there. Here CH3 is there. That hydrogen is going as H minus only it is coming and attaching here, it will be become plus. So from here one hydrogen is going to attach there, that's called 1,2 hydride shift. Now why they are doing that one? Because of what? Because to get more stability, this is benzylic carbocation. This is benzylic carbocation. Okay, this is benzylic carbocation. So that benzylic, to make it as a benzylic carbocation, they can do 1,2 hydride shift, as well as you remember tertiary carbocation, that time 1,2 methyl shift also possible. So here that is possible. Okay, that shift is possible. So here we will get benzylic carbocation rather than the alpha. Okay, that idea you have to remember, benzylic. So out of that, which is more stable, guys? Out of that, which is more stable, guys? Third one is more stable. Third one is more stable, because I already told you tertiary butyl is more stable than benzylic. Then after that, second one will come. Third one, then second one will come. Then after that, which one will come? The first one will come. Then after that, the fourth one will come. Option 3 is the correct answer. Ready, guys? Ready? Yes, all of you got the answer. Super. Okay, we can go to the 40th question. Now the time is 6:05, around 2 hours you were watching my classes and all. So happily you are watching, you are getting a lot of concept, I hope so. Ready now? So many are there, so many students are watching. Okay, yes, okay. So listen, what about this question, guys? What about this question? The end product Q in the following sequence of reaction is, it's very easy. Yeah, love is coming. Okay, great. Okay, so here while you are treating this one with the first one, I will write here. It's a easy question. Hisham is telling the answer. Hisham, great to see you. So Cl2, here I am treating with the FeCl3. Here what will happen? It will become chlorobenzene. It will become what? Chlorobenzene. Normal electrophilic substitution. Instead of hydrogen, chlorine will be coming and attaching. Then what is happening? Then that you are treating with what? Sodium in presence of dry ether. Sodium in presence of ether. That means you have to treat with the sodium in ether, and you have to take one more. Sodium and ether means you have to remember about this, actually benzylic, this actually phenyl only. So this is a fatigue reaction. This 2 chlorine and 2 Na will go. This is fatigue reaction. Okay, fatigue reaction. You remember, you must have to use your knowledge. Okay, you must have to use your common sense. Sir, only one chlorobenzene is there now. Why we are taking 2? According to your need, you have to take it. Okay, so here dry ether, because you are going to be the doctors. So here that will become what? That will become 2 benzene ring will be attached. That's called biphenyl. So what will be our answer, guys? Answer is third one. Third one is the correct answer. Okay, ready? Yes, everyone are telling the answers. Great to see that. Then 41st question, silver benzoate. This is silver benzoate. I will write here. This is silver benzoate, COOAG. That you are treating with what? Bromine in presence of acetone. In presence of acetone you can take, or else you can take what? CCl4 you can take. This reaction is called Hunts-Decker reaction. Okay, this is a special reaction for the preparation of what? Hunts-Decker reaction. It's a special preparation of it. This method is actually used for the special preparation of alkyl bromide, RCOAG. Okay, so RCOAG, silver salt of carboxylic acid. You learned RCONA, silver salt of sodium salt of RCOONA, sodium salt of carboxylic acid. You learned this one. Likewise, okay, likewise only. This is silver salt of carboxylic acid that you are treating with bromine. Bromine means Br2, Br single bond Br in presence of acetone, or you can take what? CCl4, that's not an issue. So once you are treating, what will happen? This CO2 will go. You can see, can you see? This CO2 will go. So that will form what? CO2 will be forming. Then along with one Ag, one Br will go. So that means AgBr will go. What will go? AgBr will go. Okay, AgBr will go. Now Br is going, Ag is going, CO is going. What is remaining? RBr will be remaining. This reaction is called Hunts-Decker reaction. Okay, Hunts-Decker reaction. Don't forget Hunts-Decker reaction. It is a special method for the preparation of alkyl bromine. Likewise, you learned Schwartz reaction for the special preparation of alkyl fluoride. Likewise, you learned Finkelstein reaction for the preparation of alkyl iodide. The same way for alkyl bromide. Okay, so here Here, what will happen? We have to remove this COOAg because Ag will go with the bromine and it will be producing AgBr and CO2, and here what will be coming? Bromobenzene will come. So what's the answer? Option 2 is the correct answer, guys. Ready? Yes. Okay. So that's great. Great to see that. Next one, 42nd question. Okay. 42nd question. What about this one? This one I already told you. If it is CCl3 or CF3, that is which directive? Meta-directive. This is meta-directive. So once you are treating bromine in presence of a Lewis acid, Fe, what will happen? That is a meta-directive. So CCl3 will try to send that bromine towards the meta direction. So CCl3 bromine option 1 will be coming. Option 1 will be coming. Okay. Ready. Come on. Okay, guys. Next we are going to the 43th question. 43. Okay. 43 question. The rate of SN1 will be negligible in SN1 purely based on carbocation. So SN1 is more stable when SN1 is more predominant when your carbocation is more stable. SN1 is least predominant, negligible when your carbocation is least stable. Now let's check about the carbocation they are going to form. What about the first case? If that bromine is going, what carbocation? Here positive will come. It's a secondary carbocation. What about the second case? You can see, guys. I hope you can see. Here double bond, here double bond, here plus charge will come. It is a allylic carbocation. Resonance stabilized carbocation. That also possible. What about this one? Listen to me, guys. This one you can see it's a bicyclic compound, but the problem is that the plus charge come here. It is a tertiary, but the problem is that plus charge is come at a bridge head. I told, not me. The great meter bread told to us like that. If there any free radical or positive charge or double bond comes at bridge head, that touch on bridge head, it will be highly unstable. So that is our answer. What about this one? That also will produce what? What about this one? Also will produce a stable carbocation. This is a highly unstable carbocation. If it is so, means what will happen? If it is so, like this, if it is bromine is here, means no problem, because bromine is going here, positive charge comes means there is no problem. Okay, here positive charge comes means there is no problem, but positive charge come here. This is bridge head. This is also bridge head. So two rings are there. They are connecting with the two carbon. That point is called bridge head. This is bridge head. This is also bridge head. So in bridge head, if there any positive free radical or double bond comes means touching with that bridge head. If double bond here plus, here negative, or connecting with the double bond or free radical, that comes means it is highly unstable. That's the concept. Ready, guys? Yeah. So out of this which is least predominant, this one will be coming. Which is most one, which one will come? This one will come, because there is resonance is possible. Allylic as well as resonance is possible. Okay, ready. Okay, yes. Okay, we can go to the next question, 44th question. What is the 44th question? The reaction. What about, this is a previous question, okay, don't forget, this is a previous question. This one, CH3C, CH3O, Na, CH3, CH2, Cl will get something. Which kind of reaction it is? What's the answer? Tell me. I'm not going to tell the answer, you tell me. Tell me, guys, come on. What's the answer for this one? I'm waiting. Rida, Snowflake, Ash. Come on, yes. Nothing. Williamson synthesis. Okay. Williamson synthesis. That idea you have to keep it in mind. This is sodium alkoxide. Okay. RONA. That I am treating with what? RX. Any haloalkane. R dash I am taking in presence of dry ether. What will happen? This Na as well as X will go and they will form what? ROR dash. I have one more doubt. Williamson continuous esterification process. That's wrong. Simply they given one esterification process. This is not esterification process. This is Williamson synthesis. Sodium alkoxide and R dash X. Okay. Yes. What about if I am taking instead of this one? Okay, Snowflake. If I am taking instead of this one, if I am taking this one, CH3C, CH3Cl. I mean, if the alkyl halide is tertiary and I am treating this one with a NaOCH3 in presence of dry ether, what will be the answer? What will be the answer? Yes. Alkene will be the answer because this cannot be tertiary. This cannot be tertiary. Always this haloalkane should be primary. If it is tertiary means elimination will take place. Elimination, not Williamson synthesis. This will be act as a elimination will take place. So here it will be forming CH3C. From here this chlorine will go. From here this chlorine will go. From here hydrogen will go. Then that will be forming CH2, double bond CH2, single bond CH3 will form. That's it. Idea is clear? Yeah, first degree alkyl halide give good yield. Yes, great. Okay. If you are taking tertiary means your answer will be an alkene. Don't forget the idea. Okay, guys? Okay. Great to see that. What about the next one? A compound. Here you have to make some correction here. A compound A on treatment with Na gives a compound A on B. Okay, B. Which on treatment with hydrogen you will get B. Okay, you will get B. B with PCl5 gives C. Like that you have to make it. Okay, so that means a compound A which on treatment with sodium gives what? You will get B. Okay, that B on treatment with hydrogen you will get C. And they are telling B and C react together give diethyl ether. B and C if you react with it together means what you will get? You will get what? B react with, the compound A on treatment with Na gives B. Okay, ready? Then B with hydrogen will give what? B with hydrogen will give, not hydrogen, B with PCl5, Okay, B with hydrogen. Then after that you are treating with PCl5 will give C. Okay, then after C react to the diethyl ether. So let's look about the, listen to me carefully. Let's look about the options. Okay, then after that we can come back. Actually, if I am taking C2H5OH, okay, there's a confusion. C2H5OH. This one I am treating with a sodium. What it will give? C2H5ONa I will get. Okay, this one only they are telling. I will correct the question. Okay, I will correct the question here like this. C2H5ONa, that will give you what? That will give you B. Okay, that will give you B. This is compound A, this is compound B. Then they are telling the compound A. The compound A. Same, the compound A react with PCl5. Again you are treating compound A, C2H5OH with what? Compound B. Okay, here again compound B means here it is PCl5. You will get what? C2H5Cl you will get. Correct, it is compound C. That's correct, this compound C. And once you are treating B and C, this is sodium alkoxide, this is alkyl halide. Once you are treating B and C, what you will get? C2H5O, C2H5 you will get. That means diethyl ether. So option 1 is the correct answer. Okay, option 1 is the correct answer, not 4. Option 1 is the correct, option 4 is the correct answer. C2H5OH, C2H5ONa, C2H5Cl. Yes, great. Okay, that's the correct answer. Okay, so option A is C2H5OH, B is C2H5ONa, and C is C2H5Cl. Ready? Okay, we can go to the next one, 46th question. While you are seeing this one, can you comment what's the name of this reaction? Can you comment? What's the name of this reaction? This is a name reaction, very famous name reaction. What's the name reaction's name? What's the name? Can you comment it? Yes, juice got split. Okay, so that is actually Riemann-Tiemann reaction. Okay, Riemann-Tiemann reaction only, this one. So here the first step is actually this chloroform will react with the NaOH. The mechanism is like that. That chloroform. I will write here. Okay, you can see then better. Good. So I'm taking chloroform. Chloroform is this one, CCl, Cl, H. Okay, this one in NaOH, OH minus is there. Whenever OH minus is coming, what will happen? Whenever OH minus is coming towards what? Towards which one it is coming? The CHCl3 it is coming, okay? CHCl3 it is coming. Whenever it is coming means that time this H will donate electron to this carbon. So H will leave us what? H2O. So now it will be become C, Cl, Cl, Cl. Here minus charge will come. Minus charge means that they are getting 2 electron. That only it means. Now in the next step what will happen? Out of this one chlorine will take electron and it will go. So now around the carbon 2 chlorine are there. They are taking 1 electron means positive and here 2 electrons are there. So charge will be become 0 and around this carbon 2 electron will be there. This is called carbene. This is called carbene. This carbene only will go and attach with what? Our phenol. With the phenol only you are treating. Here only it will be go and attach CCl2. Like that only that reaction is happening. Okay. Like that only that reaction is happening. That's the mechanism actually. So what is the intermediate you are getting? Dichlorocarbene. Option 4 is the correct answer. Yes? Ready. Okay. Ready now? Ready guys? So we can go to the next question. 47th one. What about this question? Okay. Listen to me very carefully. I will give again 1 minute for you because these all are the reaction you learned in 12th standard. That's why only I am giving this much time for you. Okay. Can you tell me the answer please? I'm waiting. Can you tell me the answer? Can you tell me the answer, guys? Okay, let me start. I hope I can start. This is the reaction they are telling. Okay, I'll start the reaction. You can see. This is the reaction I am having. I am having benzene. Okay, I am having benzene. That one I am treating with CH3, CH2, CH2, Cl in presence of anhydrous AlCl3. Anhydrous AlCl3. Now you just think about it. This will undergo heterolytic fission. The Cl will take the electron and it will be producing CH3, this is actually Friedel-Crafts alkylation, CH2 plus. This carbocation they will form. But there is a rearrangement possibility is there because this hydrogen will shift to here. They can form what? CH3, CH plus CH3. They can form. Now it is secondary. This hydrogen can shift to here. So plus charge will be coming here. So that only is going to attach to benzene ring. So you will get what? You will get this one, isopropyl benzene. Here like this, CH, CH3, CH3. This is called cumene. I hope you learn this name, cumene. This idea is clear? This idea is clear? Hello, Mr. Snowflake. Snowflake, you can chat later, okay, regarding DPS, BPS, you can chat later. Now you have to focus this one. On 5th May 5 exam is there, okay, don't waste your time. Yes, this idea is clear. Cumene we got. Then after that what they are telling, guys? After cumene, what they are telling? Okay, I will write cumene again here. The first step is clear, I hope. I am writing the cumene here. Okay. I am writing the cumene here, CH3, okay, here also CH3. Then you are treating this one with what you are doing there. You can see oxygen. You are treating that one with oxygen. Once you are treating with oxygen, that is oxidation. You learned cumene on oxidation. What will happen? You learned here that oxygen will be added between this one, CH3. You learned this idea during the preparation, okay, during the preparation of phenol you learned this idea. I hope you remember, okay. I will write this 2 oxygen here in between this one and here which is there. Here OH is there. This is actually the industrial preparation of alcohol, phenol. Industrial preparation of phenol you learned. Then while you are hydrolyzing that one, H2O you are adding, this much will be going outside and they will be giving you what? Phenol. That will be giving you phenol plus CH3COCH3 acetone you will get. You learned the idea. This is actually the industrial preparation of phenol. Industrial preparation. Large amount phenol we are preparing like this. Idea is clear now? Ready? So what's the answer, guys? What's the answer? What's the answer? Where is the answer? Is there any answer here? I think options are not given properly. I hope so. Okay, yeah. Options are not yes, here it is there, yeah, correct. Option 4 is there. Option 4 is the correct answer. CH3 twice, then phenol, then CH3CO, CH3. Yes, great. Option 4 is the correct answer. Yes. Okay. So we can go to the next question. I hope idea is clear now. So we can go to the next question. This is question number 48. Question number 48. Here the reaction that does not give benzoic acid as major product is. Here it is potassium dichromate. It's a very powerful oxidizing agent that you are treating with benzyl alcohol, means your answer should be what? Benzoic acid only. And this one, NaOCl and H2O. Okay, I will write the third option here. You are having, listen to me carefully guys, you are having C double bond O. What about the options? C double bond O CH3. Okay, C double bond O CH3. This one you are treating with NaOCl. Okay, NaOCl and H2O, and then you are hydrolyzing. I hope you remember, while you are seeing NaOCl or NaOI, that is actually the iodoform or chloroform or haloform test. What was that? Terminal methyl group. This will be converted to terminal methyl group is connecting with a carbon that contain double bond O. The terminal methyl group is converted to iodoform. Here it will be converted to chloroform. The remaining will be converted to what? C double bond O, ONA. But instead of H2O, while you are treating with H2O, that will be become what? That will be become C double bond O, OH. You will get benzoic acid. Idea clear? Guys. Okay, here also you will get benzoic acid. You will get COOH. What about this one? CH2OH in presence of camphor. That's also strong oxidizing agent. That also you will give you what? Benzoic acid. What about PCC? PCC is a weak oxidizing, a mild oxidizing agent. So that will oxidize alcohol to what? Benzaldehyde. It will give you benzaldehyde. It cannot go up to carboxylic acid. So option 3 is the correct answer. Don't forget this one. This one is important. Iodoform test is important. Okay. Ready. Okay. Ready guys? Now we are going to the 49th question. This is the question. An organic compound X having molecular formula C5H10O yield phenylhydrazone. Phenylhydrazone means it is either a ketone or it may be a ketone or it may be a aldehyde. That only can give. Okay, ketone or it may be a aldehyde. Okay, there only it can give. So we can avoid this alcohol. We can avoid it. Amyl means pendyl. Normal pendyl, we can avoid it. Okay, and gives negative response to iodoform test. They won't give iodoform test. That means terminal CH3 should not connect with a C double bond O. And tolerance test. Tolerance test is not giving, means it is a ketone. 100% it is a ketone. Okay, and it produces N-pentane on reduction. That means it contains 5 carbon on reduction, means 5 carbon it contains. So we can take the first option, 2 pendant 2 on CH3, C double bond O, CH2, CH3. What about this one? The first one is okay. They can produce what? Phenylhydrazone. That's okay. It's a ketone. It can form phenylhydrazone while it is treating with the phenylhydrazine. That is possible. And what about gives negative response to iodoform? No, it will give a positive response to iodoform test. Why? Because terminal CH3 is there, that is connecting with the C double bond O. So that is the main criteria, main skeletal structure for what? Iodoform test. That will give iodoform test. So that is not the answer. What about the third one? 3 pentanone, CH3, CH3, CH2, C double bond O, CH2, CH3. This one? Yeah. This one, phenylhydrazone they can form because it is a ketone. And iodo form does negative iodo form does yes. C double bond O is not connected with the terminal CH3. There is no terminal CH3. Terminal CH3 is there, but C double bond O connected terminal CH3 is not there. Okay. Then after that tolerance test. What about tolerance test? Tolerance test it won't give because it's a ketone. So that's our answer. That's our answer. Not pentanol. Not pentanol. What about pentanol? CH that gives what? Tolerance test. That's not the answer. Amyl alcohol means pentanol. Okay, normal pentanol. That only called amyl alcohol. So this is our answer. Idea is clear, guys? Ready? So option 2 is the correct answer. So we can go to the next one. The 50th question. Yes, we can celebrate. Put some fire. Come on. 50th question. Come on. Put some fire. Put some heart in the comment box. Come on, guys. Then we will start with the 50th question. Yes. No, juice got spilled. Some cases only it will give. Okay, not everything. Okay. So we can go to the next one. Which of the following reagents would distinguish cis cyclopenta 1,2-diol from trans isomer? Okay. So the thing is that cis cyclopenta 1,2-diol. Okay, I'm drawing that one like this. You can see here OH is there. Here OH is there. Both are in same side. Okay. That one, if I am treating with acetone, okay, I will take the first option, acetone. Acetone is this one, CH3, okay, C double bond O, okay, CH3, C double bond O, and here also CH3, that is acetone. Okay, guys, CH3, here CH3, okay, CH3, what will happen, guys? You learned a ketone treating with a diol, what will happen? From here, H2O will go, okay, that's the final reaction, and what it will form, you learn this reaction, okay, you learn this reaction like this, it will form what? Here oxygen is there, here also oxygen is there, that is connecting with what? That is connecting with the carbon, okay, that carbon contains CH3, this is called cyclic ketal. Cyclic ketal formation will take place for cis. If I am taking trans means what will happen? If I am taking trans means one OH will be in this side, one OH will be in opposite side. They cannot form that cyclic ketal. So that only the answer. But what about this one? Reaction with ozone. Same reaction only they will give. With the MnO2 same reaction only they will, because cis and trans there is no difference. Okay. What about aluminium isopropoxide? That also will give the same reaction with that one. So the answer is what? Acetone. Okay. Acetone. Yes. Okay. So the next one 51. Okay. 51 the question. What about this one? The correct structure of the compound A formed in the reaction. Here you can see hydrogen gas in presence of palladium carbon ethanol. You have to remember, in the case of palladium, listen to me, in the case of palladium and carbon ethanol, they are selectively, they will reduce double bond only. It will selectively reduce double bond. Selectively reduce double bond only. It will selectively reduce double bond. So, no, not 4, okay. Not 4, okay. Yes, I am Spark, star your student. Okay, great to see you, Mr. Leo Entertainment. Okay, yes, okay. So, listen to me. Here, not the fourth one. Selective reduction only on double bond. It won't affect the double bond O. So, that means this double bond only will be, here there is no reduction in ketone side, where only it will undergo reduction in the double bond, means that double bond will become single bond. That means here hydrogen will be added, here double bond O will be there. Your answer will be option 2. That idea you have to keep it in mind, okay? You have to keep it in mind. Ready now? Okay, not option 4, okay? Don't be fall in that such kind of question, okay? Here in palladium in presence of carbon, it's a selective reduction, okay? Ready? If I am using lithium aluminum hydride means, that time you can write. Here OH will come, here which will come? HH will come. That idea you can write it, okay? So next, again I am taking the next one. The correct order of acidic strength of carboxylic acid. What's the criteria? In the case of first one, you can see, here you can see, guys, here you can see, here this group, this is actually CH2, here also CH2, they are electron donating group. They will donate the electron to the COOH automatically, that H cannot go outside. H is always ready to go outside, then only it will be a good acid. But H cannot go outside because they are donating electron. They are donating electron to this carbon, automatically H cannot go. Okay, what about this one? Here you can see, while you are taking the second option, you can see here because of O is electron negative, that will withdraw the electron towards it, automatically H can easily leave. What about the third option? Third option also, here also what is there? Oxygen is there. Here also oxygen is there, but oxygen is far away compared to this one. This oxygen is nearby. So it will have more withdrawing effect. So which one will come? Second will be more acidic than third one, than the first one. Second one, third one, first one. Option 2 is the correct answer. Yes guys, yes guys, yes guys. Venkata Subbareddy Motkala. Yes, that's the correct answer. Okay, Venkat, that's the correct answer. Question number 53. Question number 53. What about this one? This one we discussed in the class. Today's class itself we discussed it. What's the idea? Can you tell me the answer please? Can you tell me the answer please? Come on, come on, come on. We don't have time. Come on, tell me, tell me. Tomorrow also you have mock test. So tell me what's the answer for this one. What's the answer? Yeah, in the first step, CH3, C triple bond CH. Once you are treating with a H2O in presence of H2SO4 and HgSO4, this will be shifted to here. It will be become CH3, C double bond CH. Here one H will be added. Here one H will be added. Here OH will be added. They will rearrange. How they will rearrange? H will go to here. Here double bond will come. Ketone will form. CH3, C double bond O. CH3. Option 4 is the correct answer. Ready guys? Ready, ready, ready. Mohammad Isham. Yes. Okay, great, great. So we can go to the next one. This is a very important question. What about this question? Of the following, which of the product formed when cyclohexane undergoes aldol condensation followed by heating? So let me explain the idea. Let me explain the idea. Listen to me. That's aldol condensation about cyclohexanone. Okay. This is the cyclohexanone. This is the cyclohexanone. I am drawing cyclohexanone like this. And here I need one more cyclohexanone. One more cyclohexanone I required. Okay. One more cyclohexanone. I am taking here cyclohexanone. That attached carbon is this one. This carbon. That is attached carbon, this one. That is alpha carbon. That contain alpha hydrogen. That alpha hydrogen we required. Alpha hydrogen containing compounds only, aldehyde and ketone only will show aldol condensation or ketone condensation, generally aldol condensation. So here what will happen? This oxygen will take the electron towards it. Automatically, I will draw that one with the yellow color, then it will be differentiable. Okay, you can easily differentiate the two molecule. Okay, this one we are treating in presence of what? NaOH. Okay, dilute NaOH only we are treating in presence of base. This will be shifted to there. So now I can draw what? You can see here O minus will come, here plus charge will come. So this one, can you see now? From here, this hydrogen will donate electron to this carbon back. That will become as H plus. That will become as what? H plus. So I will draw that one here. You can see. You can see cyclohexanone only in our question. Am I correct? Cyclohexanone only. Yes, yes. Cyclohexanone. Okay, not cyclohexane. Cyclohexanone. Cyclohexanone cannot undergo. Cyclohexanone. Okay. So here this will be, I am writing here O minus will be there. Here plus charge will be there. That H is coming and attaching means H will be coming and attaching here. H plus will be coming and attaching here. This carbon is negative. I will draw that one here like this. You can see here one double bond O is there. This carbon is negative. That negative and this positive will attach like this. Okay. This much idea is okay. I will draw it one more time here. I will draw it one more clearly here. You can see here it will be OH. Okay. That is attaching with another ring. That ring contain what? Here double bond O is there. After that you are heating. Heating means what? Heating means from alpha. Here one more hydrogen is there. From alpha hydrogen will go. From beta OH will go. In between alpha and beta. From here OH will go, from here H will go, in between that double bond will come. So your answer will be like this. Here double bond will be there, then that is attaching with another ring. Here double bond O will be there. What's the answer? What's the answer, guys? What's the answer? Yeah, option 2 is the correct answer. Option 2 is the correct answer, guys. Ready now? So this will be the first one, but they are telling aldol condensation followed by heating. So after heating, you will get this one. Before heating, you will get this one. Ready? Yes, yes, yes. Okay. We can go to the next question. 55th question. What about the name? The IUPAC name of the following compound is. Here while you are looking, you can see this is the main functional group, C double bond, CHO. And it is C double bond O is there. That's ketone or oxo. So we can start counting from here. 1, 2, 3, 4, 5, 6. So third carbon contains ketone. So 3 keto. Okay, 3 keto. Then 3 keto and second carbon contain methyl. Why I am telling keto first? Because K comes first. Keto or oxo, both you can use. Okay, here they use keto. So 3 keto, 2 methyl. Then what? Hex 4-ene. 4-ene 1-al. That's the name. Okay, so 3 keto, 2 methyl, hex 4-enal. Option 1 is the correct answer. It's simple, I hope. It's a direct question. What about this one? What about this one? What about this question, guys? A compound A, C8H10O, is found to react with NaOI. Yes, yes. While you are looking that one, you must have remember NaOI. NaOI is what? Sodium hypoiodite. That is actually you are getting NaOH and I2. You have to mix NaOH and iodine. You have to mix. You will get sodium hypoiodite. If you are mixing with a bromine, you will get sodium hypobromite. You will get. Okay, so NaOH plus I2 you have to mix. They are asking about what? Reacting NaOH produced by reacting Y with Na. So Y we got I2. Okay, and yield a yellow precipitate. That means they are giving iodoform test. They are giving that only. It means which compound having a characteristic smell. Which compound? So we have to check whether it will give iodoform test. No. What's the iodoform test criteria? A terminal CH3 should be there. That should be attached with a carbon. That should contain either double bond O, or else terminal CH3 should be there. That should be attached with a carbon. That should contain OH, or a terminal CH3 should be there. That should attach with a carbon that contain halogen. This one should be either aldehyde or ketone. Okay, aldehyde or ketone. This one is, there is no such kind of thing. What about here? Here also there is no such kind of thing. What about here? Yes, here it is there. CH3, terminal CH3 is there. That is attaching with a CHOH. That's correct. They can give iodoform test, and instead of that one, iodine is there. So that's the answer. This is not the answer. This is not the answer. So option 2 is the correct answer. Option 2 is the correct answer. How it will be 3? 3 is wrong. 3 is wrong. How it can give? It cannot give. Why? You just think about it. Hello? Think about it. CH2, OH. This OH attached carbon, this carbon, it is not attached with what? A terminal CH3. There is no terminal CH3 there. Terminal CH3 should be there. If here one CH3 is there, means that can show. But there is no CH3. So option 2 only will come. Option 2 only will come. Idea is clear? Ready, guys? Ready? Yeah. Okay. Then we can go to the question number 57. 57. Again 57. We are taking this acid. You can see. Okay, this acid, COOH, phthalic acid we are taking, and we are treating with ammonia. 2 ammonia if I treat means it will be become what? It will be become COO minus. This will donate NH plus. This will donate H plus. It's acid. So that H plus will be gained by NH3, and it will be become what? NH4 plus here. Ammonium. Okay, this will be ammonium ion, and here also you can see COO minus, and here NH4 plus will come. This one you have to heat it. This one you have to heat it. This is the compound you are getting. They are telling you have to heat it further. Okay, COO minus NH4 plus. Then this one again COO minus NH4 plus. This one you have to further heat it. Strong heating. While you are looking the options, here strong heating is there. So you are strong heating. That time what will happen? From here that NH3 will be going. Then it will form what? It will be forming C double bond O will be there. Here also C double bond O will be there. here which will be coming? NH will come. Okay, here which will be coming? Here you can see NH will come. So they will form what? Option 2 will be the correct answer. What's the answer? Option 2. Yes, option 2 will be the correct answer. They will be forming thalamide. Okay, they will be forming thalamide. Thalamide. This one only used for the Gabriel thalamide synthesis. Okay, Gabriel thalamide synthesis. From here, which one will be eliminated? NH3 will be eliminated and 1H2O will be eliminated. Then you will get that one. Okay, ready guys? So we can go to the next question. This is the question. Cannizzaro reaction is not shown by which molecule cannot show Cannizzaro reaction? So the idea is for Cannizzaro reaction, there should not be any alpha hydrogen. So this is your functional group. Okay, this is your functional group that attached carbon that contain no alpha hydrogen. So it will show Cannizzaro reaction. What about this one? This is your functional group CHO that attached carbon. This also contain no alpha hydrogen. What about CH3CHO? CHO is your functional group that attached carbon is alpha carbon that contain 3 alpha hydrogen. So it won't give what? It won't give Cannizzaro. Not shown by means it won't give Cannizzaro reaction. It will give you which reaction? Aldol condensation. HCHO means CHO is attached with H only. There is no alpha hydrogen. Option 3 is the correct answer. Ready guys? Ready. So we can go to the next one. Question number 59. Benzaldehyde can be prepared from. This is the answer. I hope you know this one is the answer. This is called which reaction? What's the name of the reaction? What's the name of the reaction? This is the answer. What's the name of the reaction? Tell me. What's the name of this reaction? I am taking benzoyl chloride. Benzoyl chloride I am taking and I am treating with hydrogen. Okay, in presence of palladium and barium sulfate. And from here, hydrogen and chlorine is going here. Barium sulfate act as a poison. Okay, poison. If I am not using barium sulfate means it will be go to benzyl alcohol. Yeah, Rosenmund reduction. Here CHO will be forming. Option 1 is the correct answer. If I am doing this one, SN bar HCl means that is actually reduction. That will give you what? Here C will be there. Here it will be become CH2NH2. Benzyl amine you will get. If I am treating this one, what about this reaction guys? This reaction, second one. The second one, bromine and KOH. While you are seeing that time you can see Hofmann bromamide reaction, degradation. So this CO will go, that will give you aniline. What about this one? Benzene diazonium chloride in presence of water. Yes, that will give you phenol. Okay, that idea also you learned. Okay, diazonium salt, that idea you learned. So our answer is first one. Okay, so we can go to the next question. Question number 60. Ease of nucleophilic addition in the given compound is. You learned the idea. Aldehyde and ketone, there only you are learning about nucleophilic addition reaction. In the case of aldehyde and ketone only you are learning about nucleophilic addition reaction. That nucleophilic addition reaction is more in aldehyde. Aldehyde will be giving more. Okay, you know the basic idea. I am not wasting my time. Aldehyde is giving more nucleophilic addition than, this is aliphatic aldehyde than aromatic aldehyde than ketone. This is actually the order. Aliphatic aldehyde will give more. No need to explain now. Tell me in the comment box. No need to explain this theory, right? Rita, Ash, Venkata Subbareddy, Motkala, Jodi, Emin. No need to explain this theory, right? You know the idea now? Okay, clear. Okay, so here aliphatic aldehyde is more reactive than aromatic than ketone. Now we can come back here. What about this one? You can see this is actually the aldehyde. So that is more reactive towards the nucleophilic addition reaction. So 2 will be more. Then after that this is ketone. This also ketone. After that aliphatic ketone will come first 3. Then after that which one will come? 1. So 2, 3, 1. Option 2 is the correct answer. Yes. Okay, option 2, not option 3. Rita, how you are getting option 3? This is actually what? This is actually what kind of one? Aromatic. This is aromatic one. Benzene ring is connecting with the C double bond O. So here these big groups are there. That's why it will be less. Okay. Ready, yeah. Not aromatic won't be more, right? Aromatic will be less. Aromatic ketone will undergo less. What is nucleophilic addition? Here, this is nucleophilic addition. Here, C double bond O is there. Listen to me very carefully. No, not I didn't give. What I gave, dears. Listen to me. What I gave here, you can see. Aliphatic aldehyde, then aromatic aldehyde. Then ketone. If you don't know means you can write aliphatic ketone, then aromatic ketone. This one I was talking about aliphatic aldehyde, aromatic aldehyde, then aliphatic ketone. I will tell you, no problem, I will explain, okay, no issue at all. This is the idea. I am having a carbonyl compound. I will explain, okay, don't worry, I will explain, okay. Yeah, I will explain, okay. So here, this is our aldehyde or ketone because carbonyl carbon is there. Whenever a nucleophile is coming means this oxygen will be shifting, taking electron towards it. That will be become what? O minus, and this carbon become plus charge. So this nucleophile, whenever the positive charge on this carbon increases means this nucleophile can easily come and attach. So here you just think about if it is alkyl group and here it is H means what will happen? This alkyl group will donate electron to this carbon, that will decrease the positive charge, automatically nucleophilic addition will be decreases. That's why only I am telling aldehydes are less reactive. Okay, aldehydes are less reactive compared to if both are hydrogen means that is formaldehyde. Formaldehyde is more reactive than any aldehyde. Is it okay, guys? Ready? Formaldehyde, then after that aldehyde will come. Then if it is benzene ring means what will happen? Benzene ring means what will happen? That will take the electron towards it. From here, that will take the electron. Automatically that carbon, you know the resonance. If it is benzaldehyde means, benzaldehyde is very less reactive because it will take the electron towards it. Automatically there is no positive charge on that carbon. There is no positive charge on that carbon, okay. There is no positive charge on carbon. Automatically nucleophile here positive charge, here plus, here nucleophile cannot come and attach to where? This carbon. So that will be less. Then what will happen if both are alkyl group means that is ketone. That time this positive charge decreases further again, as well as there is a steric effect is there because of this alkyl group. And you just think about both are benzene ring means what will happen? That will be very less reactive. So what's the order, guys? Here the order is aliphatic aldehyde, then aromatic aldehyde, then aliphatic ketone, then aromatic ketone. Among them, the most reactive is HCHO. That's it. Idea is clear? Ready? So we can go to the next question. Guys. This is our question. What about this question? This is actually SOCl2, okay? Not COCl2, SOCl2. What about the answer, okay? And what about this one? You are having CH3COOH, okay? I will write here CH3COOH you are having. CH3COOH, C double bond OOH. This one you are treating with SOCl2, thionyl chloride. What will happen? Instead of OH, which group will come? CH3C double bond O. Instead of OH, which group will come? Cl will come. You learn the reaction, okay? Cl will come. Then that one you are treating with what? This one you are treating with what? Benzene in presence of anhydrous AlCl3, okay? This one you are treating in presence of benzene in presence of anhydrous AlCl3. That is nothing. That is actually Friedel-Crafts reaction. That means I will write it properly. Here I am having benzene. That benzene I am treating with what? This CH3COCl in presence of anhydrous AlCl3. That only they are telling, okay? You must have to understand whenever you are seeing AlCl3, that time you must have to understand it is Friedel-Crafts reaction. So now what will happen? This chlorine will take the electron towards it. It will become CH3C double bond O plus. It is a electrophile. That electrophile will go and substitute benzene ring. So here what will happen? C double bond O, CH3 will come. Acetophenone will form. Acetophenone. After that, what they are telling? After acetophenone, you have to treat that one with HCN. Acetophenone. This is your acetophenone. Okay, guys. This is your acetophenone. This is your acetophenone. That acetophenone. This is your acetophenone. That one you are treating with what? You are treating with HCN. Hydrogen cyanide. You have to treat it. You have to treat with, okay. So what will happen? Cyanohydrin will form. This will be shifted to here. So benzene ring will be there. You remember the nucleophilic addition reaction example. Here O will be there. Here CH3 will be there. This will be minus. This will be plus. So this H will be H plus and Cn minus. H plus will be attached here. Cn will be attached here. Next step, you are hydrolyzing it in presence of H3O plus. What it is forming? What it will be forming? I will draw here. You can see benzene ring is there. Here C is there. Here OH is there. Here CH3 is there. And here what is that? What is happening? Here Cn will be on hydrolyzing. It will be become COOH. What's the answer? Acid. Yes, acid. It will be become acid. So what's the answer, guys? What's your answer? Benzene ring and COH, CH3, COH. These both options are correct, okay. Both options are correct only. So, both options are correct. Both are same only. That's the answer. Ready, guys? Ready? Okay, now ready? Yeah, both options are correct. Both options are same only. OH, CH3, COH. Okay, small mistake. So, okay, both are same. Okay. Yeah. So, we can go to the next one. 62nd question. 62nd question. Okay, this is the question. An electrolytic reduction of nitrobenzene. Okay, nitrobenzene in strongly acidic medium. This is nitrobenzene. This is nitrobenzene. Okay, guys. This is nitrobenzene. This one on what? Electrolytic reduction. Meaning you have to add hydrogen, that only it means, and you have to remove oxygen. While you are doing that, will be forming NHOH, okay. Hydroxyl aniline they will form, okay. Hydroxyl aniline they will form. And this is unstable because in acidic medium, okay, strongly acidic medium, what they will do? They will actually rearrange. Here one H is there, that H will go to there, OH will come to here, that will be forming what? That will be forming what? Here it will be forming NH2 and here OH will come. So what's the answer? What's the answer? Para-aminophenol you will get. Para-aminophenol you will get, okay. That will be forming para-aminophenol you will get, okay. This is the idea, para-aminophenol, okay. Ready? So we can go to the next one. This is the next one. The following reaction, okay. You can see here you are having aniline is there. You are having aniline is there. Aniline I am writing like this. NH, H I am writing. That one I am treating with what? You can see guys. Benzoyl chloride, okay. Here it is benzoyl chloride you are having. That benzoyl chloride you are treating, here H and Cl is going, that benzoyl group is substituting. This benzoyl substitution is called Schotten-Bowman reaction. What reaction? Schotten-Bowman reaction. This will be happening in the case of what also? In the case of phenol also. So that benzoylation is called Schotten-Bowman reaction. What? Schotten-Bowman reaction. Okay guys, ready? Next one, question number 64. Method by which aniline cannot be prepared is. What about the first one? You are conducting reduction of nitrobenzene. Okay, you are having nitrobenzene, that you are treating with what? Hydrogen in presence of palladium and ethanol. So here it will be reducing like what? It will be reducing it into aniline. You learned that one. That is okay. What about the second one? Potassium salt of thalamide. What about potassium salt of thalamide? This one. Potassium salt of thalamide is this one. This one only. This Gabriel thalamide synthesis. C double bond O. Here C double bond O. Potassium salt means N minus is there, K plus is there. This one you are treating with chlorobenzene. Chlorobenzene, they are telling you will get what? You will get after chlorobenzene, you have to treat with chlorobenzene followed by hydrolysis with aqueous NaOH solution. That is wrong. That is not possible. Why? Because this chlorine cannot leave as Cl minus. It will form what? Phenyl carbocation. This is unstable. That reaction is not possible. That you remember, you learned like what? Gabriel thalamide synthesis. Gabriel thalamide synthesis. Okay. Thalamide synthesis only applicable only for the formation of primary alkyl halide only you can use it. Okay, primary alkyl halide only you can use here. You cannot use haloarenes. You learned that idea, yes or no? So which option will come? Second option will come. Second option will come. What about the third one? Third one also correct only. Hydrolysis of phenyl isocyanide. Phenyl isocyanide is this one, NC. Phenyl isocyanide is NC. That you are hydrolyzing with acidic medium. Okay, what will happen? That will produce you what? This NH2 will be producing, and this will be become HCOOH. Formic acid will be forming. Listen to me. This idea you have to remember. If I am taking RCN means RCN, I am hydrolyzing means it will be giving you what? RCOOH. Carboxylic acid you will get. Instead of that, if I am taking RNC means if I am conducting hydrolysis means here it will break and it will be become RNH2, and this will be that C now, that C will be oxidized to what? Formic acid. Always one product will be formic acid. Okay, so here anyhow what we are getting? Here we are getting aniline. That also correct. Degradation of benzamide with bromine in alkyl medium. That also correct only. This is benzamide. C double bond O NH2. That you are bromine in presence of NaOH. What will happen? This C double bond O will go. Then instead of that NH2 will come. That also will give the correct one, but except the second one. Gabriel thalamide synthesis, during that time we can only use the primary alkyl halide. We cannot use what? We cannot use aryl halide because that breaking is not possible. Ready? Okay, ready? That's the order of functional group nomenclature and all. You can just take the NCERT. There it is there. You can, if you don't have NCERT, mean you just Google it. You just type organic chemistry. Okay, that basic principles and techniques. There itself that order they given. Why I am wasting my time? Okay, yes bro. So this the next one, 65. Okay, 65. You just check it. Okay, which one of the following nitro compound does not react with nitrous acid? That's actually related to Victor Mayer test only. But anyhow, you just have to remember the nitro compound that will react with nitrous acid is only nitrous acid is only the one which contain acidic hydrogen. That the one with contain acidic hydrogen, alpha hydrogen, NO2 group attached carbon should contain alpha hydrogen. Here NO2 group is there, that attached carbon contain alpha hydrogen, so that will react. This NO2 group is there, that attached carbon is there, that hydrogen, that contain alpha hydrogen, so that will react. This one won't react. Why? That attached carbon does not have any alpha hydrogen, no alpha hydrogen, that won't give. What about this one? NO2 attached carbon is there. That carbon is alpha carbon. Okay, that alpha carbon contains hydrogen, so that will give. So this is only the answer. That's only the exception. Okay, third one. Okay, we can go to the 66th one. The compound A, nitrogen containing aromatic compound A react with SnHCl. Okay, some compound A react with SnHCl. Okay, followed by HNO2. Okay, so here some compound B you are getting, then you are treating with HNO2, that give an unstable compound B. Okay, unstable compound B. Here something is happening. Okay, unstable compound B, which on treatment with phenol forms what? A colored compound. A colored compound means azodite will be. What will be happening? SnHCl. Here it will be, you are getting aniline, you will get here. Aniline. This aniline you have to treat with HNO2. That time I will write here. Okay, I will write here. You can think about it. Aniline is there. That aniline is there. Okay, aniline is there. This aniline you have to treat with NaNO2 as well as HCl. That will give you what? benzene diazonium chloride, you will get this benzene diazonium chloride, okay guys, that you are treating with the phenol. This is phenol, here hydrogen is there, that you are treating with the benzene diazonium chloride, okay, N2Cl, N2 plus Cl minus, and benzene is there. Once you are treating, this hydrogen and Cl will go, that will form what? Di, they will form, OH will be there, benzene, then diazo will be there, N double bond N. Here this group will be there, okay, that will be there, okay, that's a compound, that's actually colored compound. Here this NH2, how I am getting? By treating nitrobenzene with SN bar HCl. So our answer is nitrobenzene. Our answer is nitrobenzene, not one, nitrobenzene. Ready guys? Ready? So this one, while you are treating with SnHCl, you will get aniline. That on treatment with HNO2, you will get what? Benzene diazonium chloride. That on treatment with phenol, you will get what? Azodi. That's it. Option, which one will come? Option 2 will come. Okay guys, ready? Then we can go to the next question. Next question, this is the next question. The correct increasing order of basic strength of the following compounds. In the case of aniline, okay, aniline, you can see, in the case of aniline, here lone pair is there. And here if there any electron withdrawing group is there, means basic character decreases, because of that lone pair they can donate to someone, but here this electron withdrawing group that will try to withdraw the electron towards it, automatically basic character decreases. And here aniline is there, okay, aniline is there. Here in aniline some electron donating group is there. Then what will happen? That electron density will increases, basic character increases. Okay, that idea you have to remember, means it is easy question, okay, it's a easy question. Here what about this one? First you have aniline, okay, first you have aniline, and the second one, here which group is there? NO2 group is there, okay, here along with NH2 at para NO2 group is there. Here which group is there guys? Here along with this one NH2 is there, as well as here CH3 is there, okay. So here what is happening? NO2 group is electron withdrawing group, automatically its acidity, sorry not acidity, basicity decreases. And what about the CH3? That will donate the electron, automatically electron clouded, electron density increases. So third will be more basic than the first one, than the second one. So third one will be more basic, than first one, than second one. Option D is the correct answer. Ready guys? Ready? Rita, hello, all of you are listening now, yes or no? Rita, Ash, juice got split. Jodi Shanmugam. Yeah, after this session, I will send this PDF, okay, don't worry, I will send this PDF in the group. If anyone need, means I will share my number also, you can send through the WhatsApp, I will send it, don't worry, okay. Yes sir, okay, fine. So we can go to the next question, okay. We can go to the next question, 68. The amine that react with the Hinsberg reagent. Means either it may be primary or it may be secondary. And they are telling give an alkali insoluble product, means it should not be primary, because if it is primary means it will react with the Hinsberg reagent and it will be soluble in alkali. Secondary means insoluble in alkali. So what's the answer? Secondary. This one is secondary, this one is tertiary, this one is primary, this one also primary. So answer is the first one. First one is the answer. Okay guys, we can go to the, you have to remember methyl means one carbon. So after that one will come, 2, 1, 3. That only you have to remember. The other one is opposite. So in the case of which one? CH3 twice NH will come, then 2, 1, 3. So first one will be the answer. Ready guys? Okay, hi Vishnu Prasannan. Yes. Okay. So we can go to the next question, question number 70. Question number 70. What about the question here? This is a very important question. The correct order of basic strength of the following are. It's an important question, okay. I will draw that all structures here. Listen to me very carefully. It's an important question. Here they given, what about the figure? Here it is NHCOCH3, okay. NH double bond O CH3. This is acetanilide, you learned. What about the second question? I'm sorry. Second question, guys. Second one, CONHCH3, okay. CONHCH3. Here, C double bond O NHCH3. Okay, and what about the fourth one? Fourth one is COCH2 NH2. Okay, here benzene ring, then after that C double bond O CH2 NH2, and after that which one is coming after that? This one. Okay, this one. What about this one? Benzene ring NH2 COCH3. Okay, so this one here benzene ring, here C double bond O CH3, here NH2 is there. Now you just think about it. Only one idea you have to remember, that nitrogen should have to donate that lone pair, then it will be more basic to donate someone. Okay, so out of this you can see here that lone pair is there. That lone pair can be either shifted to here or it can shift to the benzene ring. Both can take. That's why the other foreigners cannot donate this lone pair by this one. What about here? Here this lone pair can be taken to here or it can be taken inside, but here one problem, one positivity is there. The CH3 group is electron donating. So that will donate the electron pair to nitrogen, automatically electron density will be increased as compared to the first one. So that is more basic than this one. And what about here? Here this NH2 is outside, not inside, there is no resonance. So it is actually connected to CH2 only, that lone pair they can donate to someone, no problem at all. What about here? This NH2 is actually free only, but that can be taken to benzene ring. This is aromatic only, but not like this one. Only aromatic, benzene ring only taking, not CO. So which is more basic here? The more basic one is this one. The third one will be more basic. Okay, while you are looking here, you can see the third one. This one will be more basic. Third one is more basic. Only one option is there, third one. After that, which one will come? Fourth one will come. After that, the second one will come, because here to this nitrogen, this methyl group is donating. Here, what about this case? This electron, it is what I tell, PT. This nitrogen is PT nitrogen only, because both C double bond O as well as benzene ring is taking the electron. So that become least basic. Option 4 is the correct answer. And guys, the last and final question, I think this is the last and final question. Okay, 71 question only I prepared for you. This is the last question, guys. Listen to me very carefully. So here, this one I am treating with NH2OH CH3COCl. What will be your answer? I am waiting for that answer, then we have to finish it. It's a very important one. Which one is your answer? This CH3COCl, one equivalent means that will produce CH3CO plus. That have to replace one hydrogen. Which hydrogen they will replace? Yes, this NH2 is more reactive than OH. Okay, that idea you have to remember. NH2 is more reactive than OH. So instead of this H only, which will be coming here, that OH H will be there. This NH2's H will be replacing, and their COCH3 will come. Option 1 will be the correct answer. So we discussed the 71 question. I think almost all concept we covered in this session. Now the time is 7:12. Around 3 hours 12 minutes we took. Major 71 question we did. I hope this was a wonderful session. I hope so. Is it so? Tell me, comment in the comment box, please. Come on. Yeah, PDF I will send it. Okay, you have to connect with the Brilliant Qatar number. You can see through that. You can. Jyoti, I hope you are Brilliant Qatar student only, right? Jyoti, are you from Tamil Nadu or are you from here? Yeah, you can connect with the Brilliant Qatar number. Okay, there we will send it. Okay, don't worry. The students also are studying in Brilliant Qatar. We will post in the group. Okay, don't worry about it. Okay, guys, ready now? So study hard, guys. Work hard, guys. Only 5 more days. Okay, I think organic chemistry dhamaka is exploded. Okay, this 3 hour was an awesome session. I hope so. Anyhow, study well. We have to get a very good rank, and we need only one seat now. We need only one seat. 25 lakh or 30 lakh, that is none of our business. Okay, we need only one seat. One seat for MBBS. Okay, one seat only we required. Okay, we don't want to bother about the others. Okay, you just leave it. Okay, and you just have to work hard. We are going to crack it, guys. Okay. See you in the next session. Thank you. All the best.